Okay, so if there is someone from the Geeks for Geeks team, can you please give me the permission to start sharing my screen or make me the host? Okay, I can see a couple of messages from you all. So Ayush, this meeting will be for 3 hours from 7 p.m. to 10 p.m. and it will be for 3 days. I will give you the complete background regarding it. Just let me do my setup first. Okay, just give me a one more second. Let me connect my camera as well. So guys, please don't request for any kind of access. Okay, it is just popping up in my screen. Just give me one more second. Okay. So I hope you guys can see me as well, right? And now let me share my screen once again. Yeah. Okay. So yeah, this is okay. Again, I think there is some problem while sharing the screen. Again, someone from the Geeks for Geeks, can you please give me the permission? I think. Okay, please make me the host. Yeah. Okay. Now I have the permission once again. Okay. I hope you guys can see my screen. So let me give you first of all a background, agenda for this training. So today is the day one. This is a 3 days workshop on DevOps. Okay, so it is. I hope you guys can see what exactly I'm writing over here. So this is a 3 days workshop on DevOps. In this 3 days, we are going to create one project. The project would be a movie streaming application. So it would be similar to Netflix, right? So we in the day number three, we are going to create one Netflix kind of application. Okay, that would be again a full stack application. Full stack application means it will have a front end, it will have a back end, and it will also have a database. And we will see how can we deploy this kind of application via DevOps, via CI/CD pipeline, okay, in AWS cloud. So this will be our final goal. This will be our final practical, which we will see in our day number three. Okay, so we are going to create some Netflix kind of application. Again, please don't draw anything on my screen. I can see. Wait, let me. I hope you guys can also see someone. Please don't draw anything. Or if someone is there from the Geeks for Geeks, can you please remove that permission from the participants? Yeah. So, so our final goal for this particular training will be again, guys. Please don't draw. Let me draw. Okay. Please don't draw anything in my screen. Otherwise, how we are going to learn? Okay. So if we have anyone from the Geeks for Geeks, can you please remove this permission? I think screen sharing permission from the participant. Then I think because some of you might be, let's say, join this particular workshop from mobile, and in mobile, if you just use your fingers, then it will be visible over here. Again, anyone is there from Geeks for Geeks who can remove this permission, please, from the other participants? Okay, just give me a second. So this is the first day, guys. So let us do some setup over here. Let me check. Okay, let me share. Let me stop sharing my screen for a minute once again, and let me change some permission. Okay. Mm, okay. So okay. So I hope this will not be a problem now. Okay. So guys, let's come back to our agenda again. Those people who have just joined this workshop. So I was explaining that we are currently in a 3 days workshop on DevOps. And the final goal or agenda of this particular training will be to create and to deploy a movie streaming application. Movie streaming application means application like Netflix where you can watch movies. So we are going to take a full stack application and then we are going to deploy that full stack application on AWS cloud via CI/CD pipeline. Okay, so if you are aware about Jenkins, you are aware about Docker, you are aware about Kubernetes. So all these components we are going to integrate together, and we will see our final project in day number 3. Okay, so today is the first day. Today we will learn about some basic things. Okay, what is DevOps? What is Docker? What is CI/CD pipeline? So we'll learn about it. We'll start with some basic practical today. So don't worry, this is a beginner friendly training. If there is someone who is from class 12th also, it is completely fine for me. I will start all these topics from very basics. And guys, there is no prerequisite for this training. Basic knowledge of computers will be enough. I will say a basic knowledge of Linux, if you have, will be enough for now. Whatever will be required, whatever resources will be required, I will inform you accordingly. Okay. So don't worry. And guys, there are a huge number of participants over here, so I will not be able to check your chat in regular intervals. So if you have something important, we can discuss it at a later stage. Okay, let me share my screen once again. Okay. Okay, so I have explained you my goal. My goal is by end of this training, you should be available or you should be aware how exactly we can create an end-to-end CI/CD pipeline and how can we use this CI/CD pipeline to deploy an application. Okay, here it will be a Netflix kind of application, a replica of Netflix, you can say. Okay, so we'll see about it in our upcoming classes. Right now, let's focus on DevOps. Let's focus why exactly do we need DevOps and what kind of use cases this DevOps is solving for us. And what is this term DevOps? Okay, so there are so many questions. I know it will be in your mind. So we are going to clear, first of all, these basic questions, and then we will proceed ahead with our practical. And I will also recommend one thing for you all. It will be better if you create your own personal notes while watching this session. Please don't try to do the practicals with me for first day and second day, because you may not be that much aware about DevOps. You may be a beginner. So I will recommend you to focus on the session right now. You may create your own personal notes, and after the workshop will end, you can practice it. If you're stuck somewhere, you can ask me the questions in the next class. Okay, in day number 3, when I will be showing you the final project implementation, at that point of time, you may try doing the practical along with me. Okay, so we can do in day number 3. But in day number 1 or 2, please bear with me and please try to just understand the topics first. Okay, so let's take an example first of all. Okay, so if you take an example of any company, okay, there are so many companies which are offering different kind of services. Let's say you are aware about Amazon. So Amazon give you a shopping kind of service. We have Zomato. Zomato offers you a food delivery kind of service. We have Ola. Ola offer you the service where you can book a cab. You can travel somewhere. So there are so many companies. We are in a capitalist world. There are so many companies which are offering different kind of services. Okay, so I'm starting from the basics. Okay, first of all, let's understand what are companies and what kind of services they are offering. Okay, so as we discussed, what the main goal of companies are. Okay, private companies, I will say, their main goal is to earn profit. Okay, and to earn profit, what they are doing, they are offering different kind of services. So different companies are offering different services. Some of the companies offering you cab service. Okay, some of the company is offering you food service, food delivery service. Okay, some of the company may be offering you, let's say, a social media kind of service where you can post your photos, your videos, you can share with other people's. Okay, so there could be some companies. We have Instagram, we have Facebook. So these companies are is offering you some social media kind of service. Okay, then there could be one service where you can do some shopping as well. Okay, so there are so many companies which are offering their different kind of services. Now, where exactly, in which platform they are offering you this service? So all these companies behind the scene will be running some of their servers. Okay, and then you are using their services via internet. Okay, so what all these companies have done, they are providing their services via internet to you. Okay, they have created some kind of web application, some kind of mobile application. So we are the consumers. We are the consumer for Zomato. We are the consumers for Ola, Uber, Flipkart. This what we say, all these companies. So we are the users. How are we using their application? We are using their application via internet. So would have deployed their application, their services somewhere in this world. We are the users. So we are the end users. Okay. We are the end users. We are utilizing their services via internet. So in between, we have the internet, right? And because we are using their services, so we are also paying them. That's the basic agenda, right? So now we have so many companies who are offering their services on internet. So now in this particular training, we will see how exactly these companies are deploying their application. Okay, what is the exact flow which these companies follow to develop their application and then further release that application to us? We are the consumers, so we are utilizing their application. So how exactly, what is the exact flow these companies are using behind the scene? We need to learn it. Okay, and to show you this practical, I'm going to take an example. Okay, you guys would have remembered. Okay, there was one company. Okay, let me change the color. So there was a company in 2015 around, and that company was TikTok. So what this company did, this company is also providing you some kind of social media kind of service, and this company come up with a new idea. Okay, what was the idea of TikTok? The idea of the TikTok was that you can watch and you can create a short video content. Okay, here it was around 15 seconds. And this is very important, guys. So I'm explaining you a story over here. If you understood this story, you will be able to understand the entire DevOps flow just via this story. Okay. So around 2015 or 16, I don't remember the exact year, TikTok came up. At that point of time, Instagram was also there. Okay. Facebook was also there and YouTube was also there. Okay. So these are private companies who are offering some content kind of service, some social media kind of service, and you can think they are competitors of each other. So TikTok is competitor of Instagram, Facebook, and YouTube. Okay. So now this TikTok was like a new startup. They came up with a new idea because usually in Instagram we were sharing photos. In case of YouTube, people were creating a long format video, but TikTok came up with a unique idea that let's give a chance to all the users to create a short video and then publish that video in their platform. And when this idea came up in the market, so whatever consumers who were using earlier Instagram or Facebook, and because we are using Instagram or Facebook, behind the scene, we are paying for their services. We are watching some advertisement on their platform, and that is how they are earning it. So each of this company we discussed, they have some business model behind the scene, which is being, let's say, decided by their business team. So in case of shopping application like Amazon, whenever you buy a particular product, they got a commission. Social media, they show you some advertisement, and from the advertisement, they earn. Food services, again, they have some commission. Whenever you try to buy some food item, they have some commission behind the scene. Exactly in the cab service also, they have some commission behind the scene. Okay, so each one of them have some of their business model, which we don't focus in this particular class. Our main focus would be on the servers, on the application deployment. Okay, so when this TikTok came up, almost in 2015, there were a lot of consumers who were using Instagram and Facebook. But when this new feature comes up in front of them, they start switching to TikTok. They start switching over there. Okay. Means it was a huge loss for Instagram, for Facebook, for these kind of companies, for Meta, you can say, because they were losing their consumers, they were losing their customers. And why were they losing? Because someone else, some competitor came up in the market with a new idea. Okay. So now how Instagram or YouTube have tackled this situation? Okay. So how Instagram or Facebook or YouTube have tackled this situation? So for tackling this situation, what the flow would have happened at that point of time? Okay, we have the Instagram. So in Instagram, there will be a marketing team. Okay, there will be a business team. Okay, what this business team will do, this business team will keep on looking into the market, will keep on analyzing the consumer preferences. This team will keep on checking the progress of competitors, and then this business team will come up with some kind of idea. So when TikTok was getting popularity, the business team of Instagram came up with an idea that we should also develop similar kind of feature in our platform. Otherwise, it will be a huge loss for us. Okay, so here idea came up. Okay, so whenever we talk about an application deployment, we will come to DevOps in a minute. The origin is idea. Okay, So an idea will come up. Once we have the idea, then we will see how we can develop that idea. Means how can we create the code, and once we have the code ready, how can we deploy that code in our servers. So we are right now at the first stage, how the idea will originate. So you may be a startup guy, you may come up with a new startup idea, or in this case, let's say Instagram business team came up with a new idea, and the idea was, let's develop similar kind of feature, short video kind of feature in our platform. Otherwise, we will lose so many consumers from our platform, and that will be a huge business loss for them. And we know all of these companies don't want any kind of losses. All of them are working behind the scene for profit. So they will come up with this idea. And whenever in a company an idea came up, okay, so what this business team will do, this business team will create one requirement. Means now business team have a new requirement to be developed. Okay. And here the development team responsibility will come up in the picture. So business team will communicate with the development team of Instagram or Meta, you can say. Development team. Development team means the team for developers. These are the developers who are going to write the code for it. That is the beginning, guys. In DevOps, we mainly discuss about deployment and all, but right now we are discussing about the beginning. The beginning is, first of all, there would be an idea. And from that idea, we will create a requirement document. In that document, we will mention everything, what exactly is required for this particular idea. Okay. Maybe in this document, we will mention that my user must have an option to like a reel. They must have an option to comment on a reel. They must have an option to post a reel. So everything will be documented in a requirement file. And now this requirement file is going to be shared with your development team. And development team is the one who will understand the requirement. And after understanding the requirement, they will start writing the code. And before writing the code, they will also decide the tech stack, the programming languages, which should be used for developing this kind of idea. So if you guys are working in a company, if you are working in a development role or developer role, or if you are working in a management role, whatever, so you will see this is the flow which is present in all the companies. First of all, there will be an idea from the business team. That idea will be properly documented, and then that idea will be communicated to the development team. Development team will understand that idea, or you can say requirement, and then development team is going to decide the tech stack which needs to be used. Okay, tech stack means what kind of programming languages they should use, what kind of frameworks they should use, what kind of packages they should use to develop this particular feature. And for everything, there will be a budgeting behind the scene. Again, your managers will take care of the budgeting and other stuffs. We will not go to that direction. So let's say my development team, for making it very simple for now, let's say they have decided to write the code in Python. Python is one of the easiest programming language. So your development team have decided that we are going to write our code in Python. Okay, then your development team will take some time. They may take some months, they may take some weeks for developing this particular feature. So now your development team, there will be a front-end developer, there will be a back-end developer. They all will be working together. Some of them will be developing some APIs, some of them will be creating the entire interface for you. And once the entire code is being created by the development team, let's say they took few weeks, and then the code is now ready. They are good with the requirement. They are saying that whatever was mentioned in the requirement from the business team, we have written the code for it. And now once this code is ready, now we will think of deploying this code. Because once this code will be deployed on servers, what are servers? We'll discuss about it. Once the code will be deployed on servers, then only our end consumers will be able to use my services. Okay, so I will create a fresh diagram. Okay, once again, and I will show you the entire flow right now. Okay, how it will work in DevOps. So as we discussed, there will be a business team. Okay, this business team will come up with some kind of idea. Okay, this idea will be communicated to your development team. Okay, let me write it like this. Development team will write the code for you. Okay, so they will write the entire code for you. And once the codes are created, usually development team put their code in some kind of centralized repository. because there will be so many developers who are going to work together. So in the development team, let's say we have a team of 20 members. Okay, some of them are front end, back end, and different kind of engineers. Some of them are good. Some of them will be developing a particular feature of this idea. Some of them will be developing some other feature of the idea. So they will distribute the work between them, between this team. And then once they will keep on carrying out their development, they will also create one repository. Okay, repo. And in that repo, they will keep on pushing their code. Okay, that is the initial flow, guys. Okay, we haven't come up to DevOps yet. We are still in the initial flow where we are just coming up with an idea and we are converting that idea into a code. That's what is happening right now. Okay, and now we need to understand what is this repository. Okay, and why this repository is important over here. Okay, so here there could be multiple developers, and each of the developers will be doing their programming, their coding in their local system. Okay, so let's say this developer is working on some part of the code. Okay, let's say in case of Instagram, Instagram came up with a new idea, and this idea is nothing. This is your Instagram Reels. Okay, this Instagram Reels was created to tackle TikTok basically. Okay, so for this reel, let's say this is a developer who has worked on a feature where the reels can be uploaded or where the reel likes and comment can be managed. Let's say, so this is a developer who is writing the entire code. Let's say they are writing in the code in the Python over here. They may use Java, they may use Go, they may use C++, they may use React, they may use any programming language. Okay, so it is completely on the developers. So let's say for making it very easy, they have written some of the code in Python programming language. Okay, and once the code is written by this developer, he is working on one of the component of the requirement. This second developer is working on some other component of the requirement. Now if they have to share their code with each other, okay, whatever code he has written, he want to share his code to his friend, okay, his colleague. Okay, so how can he do? Okay, so for that, because right now they are having their code in their local system. Okay, if they want this code to be shared by shared with their other developers, they will have to push this code, or they will have to put this code in a centralized location. Okay, guys, again, please don't draw anything over here. If we have anyone from Geeks for Geeks, please take care of this. Please remove this permission. Okay, so if they wanted to work in a collaborative environment where we have multiple people, all of these people or developers are working together, we will need a repository. And one of the very, let's say, easy example of a repository is a GitHub repository. So usually what we do, we create a GitHub account. Let's say this is my GitHub account. In this GitHub account, I have so many repositories created over here. I will take an example of, let's say, this repository. In this repository, let's say I am keep on putting my code. I am the first developer. I will keep on putting my code over here. I will share this particular link with my other developers. I can copy this. I can share this link with my other developers, and my other developers will also be able to see my. They will also be able to contribute my code. Like in this particular repository which I have created, here I have two contributors. I am one of the contributor, and then there is some Abhishek who is the second contributor. So we are the, let's say, two developers. We are working in the same code base. So we will have one centralized code base. In this case, this code is going to be present in a repository. How to create a repository, we will see after some time in our practical. When we will do in today's class, I will show you how to create a repository, how to connect our repository with our local system, and how to push our code from local system to a repository. So we will see that practically. But for now, to understand the entire flow, just see that here we are going to have one repository. Let's say this is going to be a GitHub repository. GitHub repository. This will be a centralized location where you will have the entire final code which will be developed by your developers. So these developers will keep on working together, and then the entire code will keep on getting stored in this particular repository. Now let's say my repository is created. Okay, and in repository, I have the final code which is being developed by my developers. So what will be the next step? Okay, so should I now go and deploy this code to my production system? So there will be a production system. Production system means basically you will have some server here. Server means you will have some kind of operating system over here. I hope you guys are aware about operating system. Like Windows is one of the operating systems. Similarly, we have different kind of operating system available. We will see a comparison and the discussion of operating system as well in this particular training. Okay. So here, let's say we have an operating system. In this operating system, we are going to deploy this application. Deploy means we are going to run this application. So whatever application my developers have created, this application is going to be running in an operating system. Okay. So if you want to run any kind of application in this world, the basic requirement is you should have an operating system. So operating system is the basic requirement to run any kind of application. Like in my laptop, I am running a Zoom application. I am running this kind of Chrome application. I am running, let's say, Spotify or Netflix or let's say Paint application. So these are different kind of application. How I am able to run it? Because I have a Windows operating system in front of me. Similarly, here also you will have to set up a particular operating system, and this operating system will be using some kind of hardware behind the scene. Okay, hardware means it will use your RAM, it will use your CPU, it will use your network drivers. Okay, so you will have to set up a hardware. Then in top of that hardware, you will have to install an operating system or set up an operating system. And in top of the operating system, you can have your application, which will be running over here. Okay. And let's say this is my final system and here is my consumer. Okay. This is my client. Okay. In case of Instagram, we are the consumers, right? We are the one who is using Instagram services. So we will connect with this particular application and we will start using these services. How we will connect? We will just go to our browser, and the browser will just hit, let's say, Instagram, and then Instagram website will be open. And from here, we will be able to see Instagram. Similarly, you have Amazon website, for example. So you can just go to Amazon.com and the entire website will be running for you. And you will be able to, let's say, do some kind of shopping over here. So behind the scene, this Amazon, this Instagram, or this Netflix, or this Zomato, okay, they will be running in case of behind the scene in top of an operating system. Okay, in the top of that operating system, the entire application would be running, which we are using. Okay, so the flow is my business team gave the idea, development team have worked on that idea, converted that idea into a code, and then normally we have the operation team. So in companies, we have the operation team. This operation team is responsible for creating your operating system. This operation team is responsible for launching or for running your application. This operation team is responsible for the infrastructure part, you can say. Okay. So here we have two kinds of team. We have one development team who is just focusing on the development part. They are not aware how exactly the deployment of the application takes place. They are not aware how the operating system works. Okay. So all this information is with the operation team. So here both the development team and the operation team are doing their respective job. Okay, but here is a catch. The catch is whatever code my developers have created, that code may have some bug. That code may have some, let's say, security vulnerability. Okay, that code may have some errors. We don't know. Okay, and we can't rely on developers directly. Okay, so whatever code is being developed by my developers over here, okay, we are not sure whether that code is properly working or not. Okay, and that is the reason, okay, we will have to, guys, again, please don't request for any kind of access. I will not be able to provide you that. Okay, so here we will have to do a proper testing of the code, because if we don't do a proper testing of the code, it may happen that you have created your application and you have deployed your application on the servers, and when your client was trying to use your services, your client got some error, your client got some bug. Okay, your client got some latency in your application. And if this kind of scenario will happen, then your client, it will be a very bad user experience. It will be a very bad user experience. And what will happen? User experience. Your user will say that your services are not reliable. I can't rely on your services which you are offering. And your user or your client or your consumer is going to switch to your competitor. And that will be a huge business loss for your company. So let's say this is a website. This is, let's say, Instagram. They were trying to work on a code and they have deployed that code without doing a proper testing on the production system. Okay. So usually this is called as production system, where your consumer directly connect and your client got some error. Let's say when you are using Instagram application, it's not loading properly. Okay. Sometimes you are able to see your data. Sometimes you are not able to see your data. Sometimes your application is getting crashed. So if you will see or you will notice this kind of issues, then you will never go back to Instagram. You will go to a competitor of Instagram, which is TikTok, which may be YouTube, or which may be some other tools. Okay. So it is very important for all the companies who are offering their services on internet to be very much reliable. Reliable means that those companies, those servers, those applications, those services where consumer can blindly rely. For example, we can rely on YouTube, because in YouTube we have seen we never see any kind of errors or any kind of bug in YouTube. And YouTube servers are always running. Whenever you go to youtube.com, you will always see the content over there. It's not like YouTube is down. Okay, it's very rare situation. So we can say that Google is very reliable company. Okay, YouTube is reliable. Similarly, Instagram is also reliable, you can say. Okay, and then Amazon is also reliable. Netflix is also reliable. So these are very reliable companies, and consumer will only go to reliable companies. And if they don't get a reliability, they will go to a consumer. Okay, so we have to make sure whatever application we are developing, that application must be reliable. And this is a very important concept, an important component. We'll discuss about reliability once again after some time. Okay, and you can consider, you may think of any non-reliable company. Let's say IRCTC. So IRCTC is usually very slow. Okay, whenever you try to connect, sometimes there's a lot of buffering over there. You are not able to book your tickets properly. So you can say IRCTC is not that much reliable in comparison to Google or Instagram or Amazon. Okay, but because IRCTC is a government website, so you don't have any choice, you will have to use it. But if I talk about a private companies, so your Zomato, your Swiggy, Ola, Uber, these are private companies. If they are not reliable, people will directly switch to a competitor until you are a government website, because for government website they don't have any choice, right? So it's very important for us, for the operation team, and for the company to make their application reliable. And how this can be done? So for this, we will now add some of the steps over here. Some steps we are going to add over here, and these steps will help us to properly test our code without, okay, before deploying it to production system. Okay. So who will help us? Guys, again, I'm not seeing right now your chats. If you are asking any question, just wait for some time. I will give you some time. So let me just complete this topic. If you have any question, just note it down in your notepad or somewhere. Once I will ask you to share your question, you can share with me. I would like to address it. Okay. So here, the first thing what we should do, we should do a proper testing of the code, because we can't rely on developers. Developers may make mistakes. So how this testing will happen? So usually we do, or we perform some unit testing. So if you are developer, you must be aware about unit testing. Otherwise, I will give you a quick example of unit testing. So let's consider that my developers have created the code, and in the code, basically they write an algorithm, and this is also called as your business logic. Okay, so your developers are going to create your algorithm over here. Okay, now that algorithm what the developers have created, you also have to properly test it. How can you test? Let's say your developer have created a very simple algorithm. Let's say that algorithm is addition algorithm, which is going to do some addition of two variables, you can say. So we have two variables, x and y. Okay, we have two variables, x and y, and now they might have created one function. So what is function? Again, it is about programming. If anyone of you is aware about programming, you may know. Otherwise, don't worry about it. It is completely the job of your developers. If you are a DevOps engineer, it's not your responsibility to focus on these things. But still, I will give you a quick example. So whenever we create any kind of business logic, any kind of algorithm, we always put it in a function. In case of Python, we use def keyword to create a function. Okay. So here we are going to create a function def, and then we will give a function name. And then in this function, we are going to write our logic. What could be the logic for doing the addition? So for doing addition, the logic is very simple. You are going to do x plus y, and then you are going to return the value of z. This is a very simple example, but in real world, your developers are going to create some very core business logic. That business logic will have multiple if conditions. It will have some loop as well. So a lot of things will be there. It's your developer's responsibility. But let's say your developer have created a very simple function, add function, and where they are doing some kind of addition. Now, how can you test whether this particular logic is working fine or not? So here your developer must also create some test cases. These test cases are going to help you to test your business logic, whether your business logic is working properly or not, or whether it has some issues. So these test cases will be required. So one of the test case in this case could be, in this situation could be that I will say, because I am the business person, I know the expected value. Okay, so whatever logic my developers are going to create, I know what should be the expected value. So let's say I will say that I am going to call this function add function, and I am going to give a pass two parameters, let's say two and two. And then I know, because this is a very basic mathematics, so I know that expected value for me, expected value for me will be 4. Okay, then what I will do, I will also call this function and I will check what is the exact value or what is the exact response I have got it from my function. Okay, and then I will do a condition. I will check whether my response is equivalent to my expected value or not. If my response is equivalent to my expected value, then I will consider this particular function is working properly. There is no issue in this function. And this is an example of one function. But you can imagine your developers will create 1,000 lines of code. Okay, hundreds of files they are going to have. In real world, whatever code we create, it is very dense. 1,000 lines of code we have, 100 number of files we have. So in that case, you will have to create multiple test cases, hundreds of test cases you will be creating to test each functionality of your application. Okay. So in this case, we got to know that our response is equivalent to expected value. So I will say my test case is passed. I am good. But let's say while doing the development, my developer did a mistake. He is a human being. He may make mistake. So let's say while doing the development, instead of using a plus operator over here, he used multiply operator. Okay. This is a bug, you can say. This is a bug. Now, if you don't identify this bug before deploying to your production system, then this will be a disaster for your company, because when your client will try to use it, some of the features of your application will fail for your client, and that will be a problem. Okay, and this is a bug. How can we identify this bug via our test cases? So what you will do, you will again call this function, and this time we have again, let's say, passed 2 and 2. And in this case, 2 into 2 and 2 plus 2 is again same value. Then that in this case, your test case will pass. But ideally, what you should do, you should call your function via multiple values, via multiple parameter. Means I should call my add function one more time with a different value, let's say 3 and 2. In this case, my expected value will be 5. My expected value will be 5. But what I got from my function, what I got from my algorithm is something else. It is something like 6. And 5 is not equivalent to 6. It means my test case has failed. It means there's an issue, there's a bug in my code. And then it means that I will not let this code deploy to my production system, because this could have a problem. Okay. So you will say your test cases have failed. So I will mark that my test cases have failed. And when your test case will fail, you will not proceed with the next steps. You will go back to the first step and you will ask your developer to fix this. Your developer will go back to the code. Your developer will identify the bug and he will then fix the bug. Let's say he will again make it plus. So this is a very lame example, but this is how we create test cases. We are going to see how the test cases and how the Python applications can be working. We will see an example for that as well in our next class maybe. Okay, so this is a main thing. Okay, so here you can see we have so many steps. The first step is idea. Second step is development team creating the code. The third step is they will upload the code to a repository. So I will just mark it first step, second step, third step, and the fourth step is I will perform a testing of the code. Okay. After performing the testing, let's consider a scenario. My test cases have passed. Okay. Let's take a best case scenario. My test cases have passed. Then again, I will be going to do some further kind of testing of my code. I will not directly deploy it to my production system, because I have to make sure whatever services I am offering, that services are reliable. If they are not reliable, my consumer will not use my services and they will switch to my competitor, and eventually this will be a business loss for us. Okay. So here the next step will be that we can also do a analysis of our code. So we have a lot of static code analysis tool available in the market. One of them, very powerful tool, is SonarQube. So what SonarQube can do for you, SonarQube can go to your code, and from your code, SonarQube can identify all the potential bugs. SonarQube can also identify, let's say in your code, somewhere you have, let's say, pass your password. Let's say here you have created a value, password value, and here you have hard-coded your password. Hard-coded your password. Now, this issue will not be identified in while running your test cases, but hard coding a password in the code is not a good thing as per security of your application. So SonarQube is very intelligent tool. SonarQube will do analysis of your code. It will go to each and every file and line of your code, and SonarQube will identify that in this particular file, in this particular line number, there's a password which has been hard coded, which is a problematic situation. So SonarQube will raise issue over here. SonarQube will raise an issue over here that you have a security vulnerability in your code. Similarly, SonarQube can also identify some of the potential bugs. There could be some bugs which you will not be able to identify while running your test cases, but SonarQube will be able to identify it. Okay, it may happen. Let me just create a fresh diagram. It may happen that you are creating a code. Okay, again, it's an example from the Python only. So if you're creating a code, okay, let's say you have created this add function. Okay, you have written the entire logic of the add function, and let's say you have created this function 2 times. Okay, or let's say in this function I have written a logic x plus y. Okay, and I will say I'm doing x plus y over here. Or let me just change it a little bit. Okay, let's say z is equal to x plus y. Let's say I have created one more function. Let's say some other function, test function, and here also I am doing something similar. So let's say here I have x and y as two of the parameter. Here let's say I have a and b as two of the parameter, and here I am doing a plus b. Now, although the function name is changed, the variable name is also changed, but SonarQube is so intelligent. SonarQube is saying that you have a duplicacy in your code. Okay, you are writing the same code 2 times, which is not good as per a good code, you can say. SonarQube will help you to write a clean code, neat and clean code, secure code, okay, and code with a better performance. So if you are creating the same function, because the functionality is addition over here, if you are writing the same functionality 2 times, so it is called as duplicacy over here. And your developer may make some duplicacy. SonarQube will be able to highlight this kind of duplicacy, and SonarQube will ask you to fix it. Similarly, it may happen you are creating your code. You may have created some variable like x equal to 10, y is equal to 20, z is equal to 100. You have created these variables, you have initialized these variables, but you are not using these variables anywhere in your code. So again, this is also not a good way of writing the code. So this is SonarQube will highlight you that there are some of the variables which you have created, which you have initialized, but you are not using them. So they are occupying your memory for no use. So SonarQube will recommend you to remove these unwanted lines. Okay. So SonarQube is one of the tool. If you just go back to the internet and search over here, SonarQube, very powerful tool. Okay. Okay. So it's an open source platform used for continuous inspection of your code quality. So it will do an inspection of your code and will tell you whether your code is written with a proper quality, high quality code it is or not. If your code is not a high quality, it will give you some suggestions to make it a high quality code. And it is very important to create a high quality code because this code is now going to be deployed into production system. If it is not good in quality, then it may cause some performance issues, some bugs, some runtime issues it may cause. So SonarQube will be able to identify these issues at a very early step, and SonarQube will help you to fix them so that before you deploy it, you are able to fix it. Okay, that's what we are going to do over here. Okay, so if I go back over here, so this is the second step which we have done, that is static code analysis. Now guys, tell me till here it is clear to all of you or not? What exactly we are going to achieve? Is it clear to you or not? The agenda is clear or not? Okay. And now if you have any queries, you can ask me in the chat. I'm just looking into the Zoom chat right now. If you are joining this session from YouTube, then I may not be able to see your chat right now. I will check it in the later stage. Clear, right? Okay, that's good, guys. So now let me create a fresh diagram. Okay, so our final goal is to create a high quality software to release high quality software for my consumers so that my consumer will keep on using my services. Otherwise, they will switch to my competitor. That is a very big pain for all the companies. They are fighting with their competitors basically. Okay, that is the reason. Okay, that is the reason your companies keep on doing some market research. They keep on looking into the market. They keep on analyzing their competitors to keep on coming up with a new idea and to integrate new idea into their application so that they can retain their consumer. Okay. So again, in MBA class, you will learn these concepts about business, but in today's class, we will discuss more about DevOps. Okay. So if I again create a diagram, the diagram was simple. My business team did some research and they identified, let's say I'm talking in case of Instagram, they have identified that there's a tool called as um, TikTok. It is getting a lot of popularity and this is causing a loss. So they came up with the idea to create a similar feature in their platform. That feature is called as Instagram Reels. I think I hope most of you are addicted with Reels right now. So it's a cool feature, I will say. And then in this reel, this idea will come up. This idea will be communicated to your developers. Your developers are going to write the code for this. And then we are going to discuss now how this code can reach to my end consumer. Let's say here is my end consumer who is waiting for this particular feature. And here I have set up one operating system, which is called your server right now. And here I'm going to deploy my application. Okay, application. So we will not directly deploy our code over here because there could be some mistakes as we discussed. So here we will follow a procedure. The procedure would be that whatever code my developer have created, I am going to first do a testing of the code. After doing the testing of the code, I'm going to check the quality of the code. Quality of code. Okay. Why quality, guys? Because it is being said in the market that anyone can write the code, but only few people can write a clean code, a readable code, okay, a quality code, a high quality code. Okay, so it is very important for you in your company, you are following the standard which is being set by the community. Okay, similarly, we have like in case of Python or if you use a node as well, we have a concept of linting as well. So what happened? It is something like whenever you are creating a code, you have to make sure that code is readable. Okay. Okay. Readable means that code must be easily understood by any other developers as well. Okay. Because your code may work, but that code may not be readable. Okay. So your code must be readable as well. Readable means whenever you are creating a function, that you have to give a proper name to your function. It is not like just give a ABC as a name. Give a proper name. What exactly that function does. Okay. And whenever you create a function, you also have to give the exact information about this function, what this function does, what this function return, what kind of argument this function takes. So again, this is not compulsory. We can still create the code without using these steps, but it is said that we should follow these steps. These are the community standards. These are the coding standard, you can say, coding standard, which your developers must follow for writing the code. Otherwise, your code may have some bug and other developers will not be able to debug it easily. That's why it is said whenever you are writing a code, you must give a proper name to your code, name to your function. You must add proper comments over there. You must create some variable name which will make some sense. Instead of creating a variable with name X, you can give a name which will be more easy to understand. Let's say you are storing here some user data. You create a variable called as user data, and here U will be small case, D will be in cap case. Okay, so this is some of the standard which we have to follow while writing our code. So we can also perform linting of the code. This linting will help us whether our code is written in a as per the coding standard or not. If it is not written as per the coding standard, we can again ask our developer to go back and to fix it. So we will not deploy that code until this is fixed. Okay, let's take a scenario. Linting is also being completed by my developer. My developer is very active. Whenever we report any kind of issue, my developer is acknowledging that particular issue and then he's working on to fix it. Okay, then the next step would be that now I wanted to, let's say, deploy this code. So I will create a bundle of this code. Okay, bundle of this code. So if any one of you are aware about Java, in Java, usually we create jar file. We compile our code and we create a jar file, and that jar file we run it in later stages. Python is an interpreted language. So you may create a bundle file Okay, let's say your code was written in a file called as app.py. In your app.py is your entry point for your Python code. Let's say you have written multiple code over here. If you want to run this code, you just have to use Python space app.py. Just run this command, your Python code will be started. Your Python application will be started. It's so simple. Okay, so I will give you an example, okay, of the Python code I may have in one of my repository. So if I go back here, let me just open any of the sample repository, okay, for Python. And same thing is applicable for any other language as well, if you are aware. So Python is one of the common language. That's why we are paying it up. So you can see in app.py file over here, we have created some Python code over here. That Python code is returning some value over here. Okay. So now if you want to run this code, what all you need to do, you just need to use Python space app.py. Your code will be running. Your application will be running. That's it. Okay. That's what we are doing. Similarly, here also, we will run our code. So you can bundle your code as a single unit and then you can run it in the later stages. Again, about bundling, we will discuss in our upcoming class in a practical manner. So this is just a theory I'm explaining you. Okay. Now, once your bundling is also done, what will be the next step? The next step is now should I deploy my code to my production system? Should I deploy it? What do you guys think? We have done a proper testing of our code. We have checked the quality of our code. Should we deploy our code to production system or not? Okay. So wait, let me check the chats as well. Again, guys, what is the best resource and all? I will keep on telling you. Okay, some of you are saying we can go, and some of you are saying no. Okay, and that is correct. We should not directly deploy our code. We still have a problem over here. The problem is our code may have still some issues which is not been highlighted yet. That's why instead of deploying our code to production system, we should deploy this code in some other system that is called as testing system or development system. Okay, so this is my production system. I will not deploy my code to production system because my real consumer is sitting over here. And I don't want any kind of bug to reach my consumer. Otherwise, my consumer will not be happy. So that's why after this, what I will do, I will go back and now I will create one operating system. Okay, and I will deploy my application over here. And this I will call as my development environment, dev environment. Okay, and this was the production environment. So I have created one more operating system. This is only for my local employees, like employees who are part of my organization. Okay, and we will call it as dev environment. And I will deploy my code over here. Once your code is deployed in this dev environment, now your developer who has written this code, your developer will come over here and your developer is going to see whether all the feature of their application is working fine or not. Because till now, when my developer was doing the coding in his local system, he was running the code, he was running the application in his local code, in his local system, in his local host, he was running. But now, how exactly that code is behaving in a dev environment, he will have to check. And once he will check, then only he will proceed ahead. So let's say we have created one Amazon kind of website. I will just show you Amazon, Instagram. Let's say just open Instagram over here. Okay. So they will ask me to log in, but let's say, let me close this. Let me go with Amazon itself. So here you can see your developer is going to check whether my buttons are coming properly over here or not, whether all the things are aligned properly or not. When I click on this button, whether I'm getting the data properly or not, whether all the feature of my application is working fine, whether I'm able to scroll it or not, whether I'm able to click it or not. So whatever requirement was shared with you at the initial phase, when your business team have shared the entire requirement with you, you have to check whether all the requirement is working fine or not. Everything is working fine or not. So dev is one of the environment where your developer is going to do some further testing to make sure his code is behaving properly over here. And let's say my developer have identified that, okay, some of the buttons are not working properly, some of the APIs are not working properly. Okay. So in that particular case, what we can do, okay, we can ask our developer, the developer, let's do one thing. Please go back to your coding environment and please update your code. Okay, he will again update his code. Again, testing of the code will happen. Again, quality of the code will check. Again, the linting of code will happen. Again, the bundle of the code will happen. And again, the newer code which your developer have created will be deployed in your development environment. Okay, that's what is going to happen. Okay, it means my developer will do an initial kind of testing, but there is a chance my developer is not that much like good. Let's say he find out some issues, but he's not he's not willing to work on that issue. He's not willing to fix that issue. Okay, and let's say he has said that okay, everything is working good, but should I deploy it to my production system? No, I will go to one more environment, and that is called as your QA environment. Okay, and in my QA environment, I'm going to deploy my code. I will say now let me ask a separate team to test my application features. Because developer is creating these features, developer will have a soft corner for this feature. Developer may hide out some of the issues which he have identified. That's why we will ask a different team, and that is called as quality assurance team. In your company, you will have a QA team, and QA team will do one thing. QA team will again take the exact document which was shared by your business team, requirement document. Okay, so your QA team is going to read this particular document, and then QA team is going to match whether everything mentioned in this particular document is available in the application or not. If anything is not available, QA team will raise it as a bug, and QA team will ask for developers to fix it. Okay, that's why it is always there's a fight between developers and QA team, because QA team is the one who will highlight the issues if they find it out. Okay, so here my QA team will identify if there is a bug. Okay, and QA team will raise that bug to my developer, and my developer will have to fix it. That's what the developer responsibility is over here, right? Okay, so now once let's say from the QA team also, QA team has also given a green signal. QA team is saying, let's take a good scenario that QA team is saying that everything, all the features, everything is working fine. Then should we deploy this code to a production system? No, we still have to do some kind of testing. Okay, so now we will deploy this code into one more environment, and usually this is called as pre-prod environment, or you can call it a staging environment. Staging environment. You may have a pre-prod environment also set up. You can go by pre-prod as well. And then in the staging environment will be exact copy or replica of your production environment. In the staging environment, you are going to deploy your application, and now you are going to further check the performance of your application. Whether all the application which you have created, is it causing any issues in the existing services or not? Okay, so you will also do integration testing basically. So let's say Instagram came up with a new feature called as Reels, Instagram Reels. But because this Instagram Reels come up in the picture, so is my Instagram notification service, is my Instagram Messenger service, or is my Instagram status service is affected or not? So we have to make sure whenever I am coming up with a new feature, my existing features are not failing; they are still working. So here, once again, we are going to check the performance of our application. We are going to check whether my application is behaving properly or not. Let's say here also we get a green signal. If we get a green signal, then only we will deploy our code to production system, which will be available to my consumer. Let's say here if we have highlighted some issues, then again this will be reported to developers. It will again go back to your developers. Okay, and your developers will have to again write the code. Once they will write the code, again testing will happen. So whatever steps we have created, this is going to be executed every time. Whenever your developer is going to update the code, every time testing is going to happen. Every time quality of the code is going to be checked. Linting is going to be done. Bundling is going to be done. Development moment testing is going to be done. QA team is going to test. Okay. Once you got a green signal from all these places, then finally, you will deploy your code to your production system. And once you deploy your code to production system, now your real consumers are going to utilize it or use it. Okay. So that will be the complete flow. Now we can have so many other steps as well in between it. I will show you these steps in my upcoming discussion. But for now, you just need to understand that we don't deploy any code directly to our production system blindly. We take that code via a proper procedure, and then once the procedure is completed, once we got a green signal from all the procedures, once all my procedures are successful, then only we take a decision to deploy to production system. Otherwise we don't deploy to production system. So our end goal is to release a high quality software. Okay, our end goal is to release those kind of softwares, okay, those kind of softwares which is properly being tested, because we don't want any bug to reach to my consumer. Okay, this is a flow. Now let's come back to our agenda, which is DevOps. So what is DevOps now? Okay, DevOps. So DevOps is nothing. It is just a set of practices which we follow to release a high quality software, to release a reliable software. So DevOps is a set of practices. What are these practices? We have just discussed. We have to test it, check the quality of the code. We have to check the linting of the code, bundle the code. Okay. So it is set of practices. Again, my spelling may be wrong, but it is set of practices. Okay. So DevOps is a set of practices. You can also consider DevOps as an umbrella of tools. So a lot of tools we are going to use under DevOps, under the hood to release a high quality software. Okay. That is our main agenda over here. The second agenda for DevOps is automation. Okay. So DevOps is saying that I will tell you a set of practices which you should follow to release a high quality software. And that is the reason nowadays everyone is following this DevOps practices. All the companies are following these DevOps practices. Okay. That is the first thing. The second thing is, guys, again, please don't draw anything in my screen. Okay. The second thing is automation. Now, why automation is required? Again, because of competitors. Okay. So let's say we have a company Zomato. So recently, Zomato come up with a new feature. I don't know if you guys are aware. Zomato came up with a feature where they were noticing again their business team were noticing from a long time that a lot of food wastage is happening in their platform. How? So let's say if some person has ordered a food from Zomato, and then the particular restaurant is let's say what we say preparing the food. Okay, so restaurant is preparing the food, and once the food is being prepared, now this particular consumer has cancelled his order. So in this case, a food, okay, wastage was happening, because what should we do with this food now? That was a big problem. So again, the business team, the marketing team of the Zomato were noticing that a lot of food wastage is happening in their platform, because some of the people are ordering the food but they are canceling it at the end moment. That's why they recently came up with a new feature. In that new feature, if someone has ordered for a food and then they have cancelled that food, then all those other consumers, all the other consumers who will be around some distance from the restaurant. Let's say they will decide that all those consumers who will be under the radius of 2 kilometers from the restaurant, they will automatically get a notification in their Zomato application. And let's say originally this food was for let's say 1,000 rupees. Now they can claim for this particular food in a very discounted price. Let's say only at 300 rupees they can get it. So now the food wastage can also be fixed, and other consumers can also get the food at a very low cost. So this is a new feature which recently Zomato came up with, and this got viral because this is helping this Zomato as well as the restaurant to utilize their inventory in a proper manner. Okay. So in that case, this is a new feature you can say they came up with in that platform. Now, Swiggy is one of the competitor of Zomato. Okay, so in that case, if Swiggy will not came up with similar kind of feature, okay, so consumers will attract to the discount which Zomato is offering, and then it will be a loss for Swiggy. Okay, that's why all the competitors which are working in the market, which are struggling to get the consumer attention, their final goal is to release their new ideas as fast as possible to their consumers. Okay, it is called as time to market. Time to market. Okay. TTM in short form. What is time to market? Time to market means whenever an idea comes up in your mind, how quickly you can take that idea to your consumer, your real consumer. Okay. All the companies want to make their time to market very quick, very fast, because they wanted to be ahead of their competitors. So if Instagram came up with this idea earlier than Swiggy, then obviously all the consumers will keep on attracting to over here, let's say Zomato, not Instagram, Zomato, sorry. So Zomato came up with this idea more quickly in comparison to Swiggy. So all the consumer will start switching to Zomato because they are getting a discount over there, and then it will be a loss for Swiggy. That's why all companies behind the scene wanted to release their new ideas very frequently to their consumers. And if you want to release your ideas very frequently to your consumers, you will have to use automation, which we are going to use in this DevOps. Okay, what this automation means? Automation means right now, let's say when my developer was creating the code, so creating the code is again a manual process. We can't automate it right now. Creation of the code is a manual process. But once the code is being created, now someone will have to perform testing over here. If you are performing testing manually, it will take time. And it maybe that you might miss some of the scenario. Okay, you might miss some of the bug. It may happen. So if you are doing the testing manually, if you're doing the checking the quality of code manually, if you're doing the bundling manually, if you're deploying it manually in your dev environment or your QA environment or your staging environment, then that is going to take some time. That's why now we want to automate this process. We want, as my developer will make some code changes, automatically testing will be triggered. Automatically quality of my code will be checked. Automatically linting will be checked. Okay. Automatically bundling of my application will happen, and automatically my code will be deployed to my dev, QA, and staging and all the involves. Okay. So we want to have automation over here because we want our software to reach to our consumer very frequently. We want to decrease our time to market. We want to make it very fast, very quick. Okay. And that's why in DevOps, you will see, in DevOps, you will see that we will use automation over here. Okay. So let's see now how the automation can be useful over here and which kind of tool are going to help us to achieve this automation. Okay. So I will just create one more diagram. Again, guys, this is the theory part which I wanted to clear for all of you to make a proper base. Once the base is clear, we will proceed ahead with our practicals. Okay. Anyone have any doubt till now, you can ask me. Okay. Okay, I can see so many people are giving their links over here. Okay. So if you have joined the session from the beginning, you will be able to understand it, guys. If you have joined in between, obviously you will not be able to understand it. Okay. If you want to learn it completely, then please, I think it may be present in YouTube. From YouTube, you may try to watch it from the beginning. Okay. So you guys can try that. But I will recommend to watch it from beginning. Otherwise, you will not be able to understand this. And here's the example which I am giving over here is one of the basic example to make everyone comfortable with DevOps. Okay, we have so many examples which I will be showing you in my practicals. Okay, so don't worry about that. We'll see about some more examples in our upcoming class. This is the first example I'm showing so that everyone is in the same pace. Okay, so I'm working with Unilever. So in Unilever, like we have deployed so many pipelines, so many infrastructure we have created for Unilever. You can say label. Okay, so we have a huge load. How we are managing the load for Unilever, because Unilever is creating so many different kind of products and which is spread across different part of this world. So how are we managing it? Again, if I will have some time, I will try to explain to you in my upcoming classes. Okay. Yes, examples again we will see in some time. Few more examples we'll be able to see. Okay. Okay. So pre-prod environments, you need what we do usually in pre-prod environment. Pre-prod is always an exact replica of production environment. Because see, production environment will always have more resources. Why? Because production environment will be used by my consumers. So in production environment, let's say, just imagine, let's say you will have almost 256 GB of RAM. You will have 16 core of CPU. Why? Because you need a high infrastructure, a huge resources you need because you have in production system. In dev environment, we usually have very less resources. Okay, because it will be used only for development purpose. We will have a development team, internal team who are going to work on this particular dev environment. So you will have all the resources. Let's say here you will have only 32 GB of RAM. Okay, 16 core of CPU you will have. Okay, so you will have limited things present in the dev environment, which will be helpful for you to perform the initial testing. Pre-prod environment will be exact similar to your production environment. Okay, entire security settings in pre-prod environment will be similar to your production environment. So pre-prod environment will give you exact feeling of production environment. So before releasing anything to production, you will see how it is behaving in pre-prod environment. In whatever way it will behave in pre-prod environment, there's a high chance exact same way it is going to behave in production environment as well. So it's exact same replica because companies or the operation people, they wanted to have a clear understanding. Okay, how my application is going to behave in production environment. So they have created an internal pre-prod environment, which is accessible only to their internal employees. Okay, their internal developers and the operation teams, where they can do a final round of testing before deploying it to your production environment. Okay, that's what we do. We will check the performance as well. How exactly my application is performing? How much time is it taking to give the response? Because we have to make sure our application don't have much latency and it has a good performance as well. Okay, that's what we see. Okay, so now let's come back to the discussion. Okay, so the discussion again is that we have an idea. From the idea, there will be a requirement. Sorry, requirement. And from the requirement, there will be a code created. And then that code is going to be pushed to your GitHub repository. So who is creating your code? Your developers are creating the code. And who will take care of rest of the part? Your operation team is the one who will take care of rest of the part. Operation team is the one who will create your entire infrastructure, who will help you to deploy your application, who is going to monitor your application. Okay. And if there is more load on your services, so they are also going to do the scaling of your application. Okay. Let's say these days IPL is going on, right? IPL is going on. So IPL is going on currently in Hotstar, I think. Okay, so Hotstar will have their own servers behind the scene. Okay, they will be running some servers over here. Okay, in this server, their entire application, Hotstar application, will be running. Okay, and they will be launching multiple copy of the Hotstar application. Why? Because if one of the application is overloaded, let's say there's a match going between RCB versus Mumbai, and let's say this is the final match which is happening over here. Let's consider RCB reached the final. Okay, so in that case, the final match is going on, and it is currently present in Hotstar website. Okay, so Hotstar application is running, and there will be huge load. There will be huge load on the servers of Hotstar. Okay, there are so many people, millions of people will try to watch this particular match. In that case, how can we manage this much huge load on our servers? Again, that will be responsibility of your operation team. Operation team will be the one, okay, DevOps team will be the one who will be responsible for handling this much huge load on the servers. So what they will do eventually behind the scene, they are going to launch multiple copy of your server, multiple replica of your server. Replica means exact same copy. Okay, so here my application is running in this particular system. Here also my application is running in this particular system. Here also my application is running in this particular system. So some of the load, I have millions of people. So some of the consumers will be diverted to this particular server. Some of the consumers will be diverted to this particular server. Some of the consumers will be diverted to this particular server. It is called as load balancing. We are balancing the load between our servers. Because if entire load went to a single server, then your server will crash. And then your consumers will not be able to watch the live match. And then this will be again a bad experience. Okay. So that's why there will be so many servers created. And behind the scene, we can also use a tool, Kubernetes, which we will learn in day number 3. Kubernetes can help you to perform auto scaling. Auto scaling means as you have more load, let's say the match was going very boring between RCB and Mumbai. Only 10 million people were watching at a point of time. It was going boring. But suddenly someone hit 6 sixes in 6 ball. And when he hit 6 sixes in 6 ball, it got viral all over social media. Now more and more people are returning to the website to again resume the match, to watch the match, because now the match is getting interested. So earlier, only 3 servers were running, and these 3 servers were able to accommodate 10 million, let's say, requests. But suddenly, because someone hit 6 sixes in 6 ball, it got viral. Now we have 20 more million people who wanted to watch match. and suddenly 20 million more people wanted to watch a match. So these many servers will not be able to accommodate this much traffic and your server will crash. So here you will have to do auto scaling behind the scene. Okay. Auto scaling will launch more copy of your servers behind the scene dynamically. As the load increases, more replicas will be created. And then here your application will be deployed. And now some of the consumers will be forwarded to these servers, you can say. So we can balance the load between our servers. Again, how to do the scaling and all, it will come under Kubernetes. We will discuss about Kubernetes as well. It will be a part of your DevOps umbrella. Okay, so we can scale our application, but before doing a scaling of application, before even deploying your application, you have to proper test your application. Okay, so that you have to make sure your application is foolproof, don't have any bug. Okay, and that's why here we have discussed about so many steps. First, we went to GitHub. We have uploaded all of our code to GitHub. We have pushed all of our code to GitHub. Then after GitHub, what we did next, we did some unit testing of the code. We did some linting of the code, lint check of the code. Lint check means it will check whether your code is written in the proper format or not, whether you are following the standard or not, coding standard or not. Okay, and then we will check the code quality as well. Okay, these are the main steps, guys. I'm highlighting. There would be further steps in between. We can add it as required. Okay, and then you can further create the bundle, and then you can deploy it to dev environment. Let's say. Now, once your code will be pushed to GitHub, what usually will happen? Your development team will send an email to your operation team and will ask your operation team, my code is being developed. Can you please start doing the test? But again, this is a manual approach. Okay. And manual approach means it may take some time. Okay. Your operation team will come up, they will manually run the test cases. It will take some time, which we can't accommodate in this fast growing world where we have so many competitors. We want our application, our idea to reach our consumer as soon as possible. We want our time to market to be very fast. That's why we will use automation over here. Automation in such a way as your code will be pushed to GitHub, automatically your unit testing will be triggered. Automatically this will be triggered. This will be triggered. So all these steps we have discussed: step number 1, step number 2, step number 3, step number 4, step number 5. Okay, all of them will keep on getting triggered automatically. And for this, we will need a tool. Okay, and this is called as CI/CD tool. And there are so many tools available. One of them is Jenkins. Similarly, if you guys are aware about GitLab, if you are aware about Azure DevOps, okay, if you are aware about this GitHub workflows as well. So these are like competitors of each other. Okay, what this tool does, this tool will help you to create this kind of automation pipeline. We call it as pipeline. Why pipeline? Because there are so many individual steps. Step number 1, step number 2, step number 3, step number 4, 5. Now we wanted to integrate all these steps. We wanted to connect all these steps. So basically, to connect all these steps, we are going to create a pipeline. In this pipeline, all these steps will be connected with each other. Means when your first step will be completed, your second step will be triggered automatically. Okay, so these all steps will be linked with each other, connected with each other, and usually we call it as pipeline. So we will have to create this kind of pipeline. This is called a CI/CD pipeline. And to create this CI/CD pipeline, we have a lot of tools available in the market. In this particular training, we are going to work on Jenkins. So we are going to use Jenkins to develop this kind of CI/CD pipeline. Okay, so Jenkins will help us to build this CI/CD pipeline where I can define that my first step will be to perform unit testing. Second step to perform linting. Third step to perform code quality. And in the pipeline, we will also define that whenever any of my step will fail, let's say while doing the linting of the code, it got failed. It is saying that your code has some problem, you have to fix it. Whenever your code will fail, you will not proceed ahead with the next step because your pipeline is broken over here. The second step got failed. So whenever your any of these intermediate steps are failed, you will go back to the initial step, that is coding. You will again ask your developers that developer, please fix this issue. And your developer will again fix it. Once your developer fix it, again he will push to GitHub. Again the unit testing will happen. Again the linting will happen. Let's say this time after updating the code, linting got succeeded. So this will be succeeded. If it is succeeded, then only the code quality will be triggered. Let's say while doing the code quality, it got failed again. So if it got failed, it is not going to go ahead or proceed ahead with the next step because it got failed over here. It will again go back and will again ask your developers. So you can share the logs to your developer and you can ask your developer to fix this issue. Once the developer fixes it, he will again push to GitHub. So it is a continuous process. Okay, that's why here the C stands for continuous. So your developer will continuously keep on working on the code. He will keep on updating the code. You will keep on testing the code. You will keep on checking the quality of your code, and you will keep on deploying your code as well. Okay, so here this CI/CD tool here, C means continuous. Okay, and I means integration. The CI means continuous integration. Integration. And CD means continuous deployment. So let me write. This is a full form. Continuous deployment. Okay. So here we are developing a complete CI/CD pipeline. Okay. This CI/CD pipeline is setting up the entire, let's say it is integrating my entire steps together. Okay. It is creating one single pipeline. If any of these steps will fail, my pipeline will be broken and it will not proceed ahead with the next step. Okay. And that's what we wanted to achieve. And here the integration means that whenever your developer will make the code, you will keep on integrating that code. You will keep on testing that code. You will keep on acknowledging that code. Okay. So in continuous integration, like this pipeline, which we are creating over here, we will further divide this pipeline into two parts. One is CI and the other one is CD. So your pipeline will be divided in two parts. And we are going to create this pipeline as well as we proceed. So just understand the concept first. So we have CI/CD pipeline. So this pipeline which we have created with the help of Jenkins, in this case, you can use GitLab or some other tools as well. All of them work similar way. They have some different options, features, but the main agenda is same. They have to create a CI/CD pipeline. The main goal of CI pipeline is continuous integration pipeline is to make your code ready for deployment. Ready for deployment. Means in continuous integration pipeline, we usually make our code ready for deployment. To make your code ready for deployment means you have to further or properly test it. You have to properly check the quality of the code. You have to properly bundle it. Once it is been done, once the code is been ready for deployment, that's it, your continuous integration pipeline is completed. Now the job of your continuous deployment pipeline will come up in the picture. Deployment or delivery, you can say. Okay. So what continuous deployment pipeline will do? This deployment pipeline is the one which is going to create infrastructure for you. In our case, it will create the operating system for us. Then in this operating system, it is going to deploy our application over here. So whatever environment we discussed, dev environment, we discuss about QA environment, we discuss about staging environment, you may have a pre-prod environment, then you have a production environment. Okay. So in these places, we are just deploying our code. So this deployment will come under continuous deployment. Continuous integration is just going to make your code ready for the deployment. Okay. And you can imagine once you have your bundle created, means your application is properly been tested. And after testing your application, you have created the final bundle of your application, which needs to be executed. Okay, which needs to be run. So till this step number 4, whatever you see from step number 1 to step number 4, it will come under your continuous integration pipeline. Whatever you will see after step number 4 will come under your continuous deployment pipeline. Okay, and together we will create an end-to-end pipeline with the help of Jenkins. Okay, so Jenkins is one of the automation tool that will help you to set up or to create this kind of pipeline over here. Okay, that's what we will be doing as well. Okay, so I hope it is clear. Okay, so the CI/CD pipeline will be created. Once your CI/CD pipeline is created, we can proceed ahead with the next step. Okay, so till now, our focus was to identify the bugs as early as we can, because if your bug reached to your production system, then it is not a good user experience. So you wanted to identify your bug as soon as possible. Okay, that's why we are performing these many steps. That's the first reason. Second reason is we want our code to be high quality, and we want whatever code we are releasing to production system, it is properly being tested, high quality, it don't have any duplicacy, it don't have any security vulnerability, it don't have any bug. And the third thing is whatever code we are deploying to our production system, it should be reliable, as well as we want our time to market to be very fast. Because now with the help of Jenkins, everything will be automated. We just have to set up this pipeline only one time. Once your pipeline is being set up, then this pipeline will keep on running automatically whenever your developer will push new code, when your developer will create new code, automatically it will keep on getting executed. Okay, so we will achieve here fast time to market. Our application or our idea will reach to our consumer very fast. And if it will reach very fast, means we will get more business, we will get more client. Okay, and that is our final agenda over here. Okay, so right now we discussed more about the continuous integration part. Now let's learn about deployment part as well. How exactly the deployment will happen. Okay, let's say you have created a bundle file over here. You have created a bundle file over here, and that bundle file you want to deploy. So in case of C++, you may have an exe file to be executed. In case of Java, you may have your jar file. Okay. In case of Node, you usually use npm build command to build it, right? So for different programming language, we have different ways available. For mobile application, you may have .apk file. Okay. In case of Python, it is a interpreted language, so we can directly run it. We can just convert it into a tar file or a zip file. We can extract it and we can run it directly, whatever file name we have. So once your bundle is created, now we have to deploy this application. This is the application which we have created. And to deploy any application in this world, the basic requirement is you should have some hardware. Hardware means you should have RAM, you should have CPU, and you should have your all the networking stuffs. Okay. In top of the hardware, you have to set up one operating system. Once you have the operating system ready, now you can deploy your application. So for deploying your application, you will need the hardware. Now, from where exactly you will get this hardware, RAM, CPU, and everything? So one of the way could be that you are a company, you can go to the market. From the market, you can buy all your hardware. Okay, you can buy all of your hardware, and then after buying those hardwares, okay, the next thing what you will do, you will buy some land as well. In that land, you are going to create your own data center. Data center is the place where we put all of our hardware devices. Whatever hard disk you have, whatever RAM, CPU, everything will be put in a data center. So if you are a company, so the first way could be that you can create your own data center. In that case, your company must have a budget for that. Your company must have an upfront amount of budget, because they have to set up a data center. Means they have to buy a land, they have to buy all these networking devices, all this RAM, CPU, and everything. Then they will need a technical team who will set up this data center. Okay, who will put all these hardware devices, and who will connect all these hardware devices with each other. Then in this data center, you will have to provide 124 into 7 electricity. Okay, then in your data center, you have to provide some cooling as well, because so many hardwares you are going to put, so you have to provide some cooling as well. Then you must have a technical team who will keep on upgrading your data center, who will keep on updating your hardware. If there's any patches, they will keep on updating it. If something got failed, they will replace it. So a lot of things you will have to do for creating a data center. Once your data center is created, you may say that, okay, my hardware is now ready. Now, in top of this hardware, I can create my operating system, and then I can create my application. But creating this kind of data center is not an easy task. So many things you have to do in the background. Like one of the issue could be, let's say you are a company. Let's say you are a startup. Okay. So what you did, you are a startup. Okay, and then you decided to launch your website or your application. So what you did, you took some money from your investors, you set up this kind of data center. This data center will take millions of rupees. Okay, millions of rupees it will take you to set up this kind of data centers. Okay, so once you set up this data center, everything is been set up. Now you have released your application. Okay, and let's say your application got suddenly viral. Okay, you expected that only 1 million consumers you will get in your first day, but because your application idea, your startup idea was so interesting, that suddenly it got viral, and now almost 10 million people is trying to use your services. In that case, you don't have that much hardware in your data center. So your application will crash. And you can imagine this is such a big problem for your company. Why? Because they are having consumers, but they are not able to serve their consumer. So your consumer will not be happy with this kind of kind of service. They will say that your application is not reliable, and then they will switch to your competitor. That's why, let's say you got created all the data center, all the hardware only for supporting till 1 million requests, but you got 10 million requests. In that case, you will have to again go to the market. You will have to again buy some more hardware. You will have to again set up those hardware in your data center. And but by then, everyone would have leave your website, right? This is a problem. And the second problem could be, let's say you have a startup, you have launched your application, and you were expecting 1 million people are going to use your services. You have bought, let's say, 256 GB of RAM, and you bought petabytes of hard disk also you bought. You bought all the CPUs, multiple core CPU you have bought. But when you release your startup idea, now no one is interested in it. It may happen. So this is a failed startup idea. Although this is a failed startup idea, but you have set up this much huge data center, which is going to be a very big issue for you, because your company may took some loan to set up this kind of data center. Your company will have to pay. Your company expected that they will get 1 million people and they will be able to serve them, but they got no one. Okay, very limited request they got. So this will be again a loss for the company. So in both the scenarios, when no one came to your company, this is a loss because you have set up this data center. What will you do with this data center now? And the second issue is, you may have set up a data center, but you got more than expected amount of consumer in your website, which your current hardware is not able to support. So that is also a problem. That's why instead of setting up our own data center, this is also called as on premises. Okay, what we can do, we can take this hardware on rent. Okay, this is the same concept. Like I'm someone who is, let's say, shifting to Bangalore. Now in Bangalore, I wanted to live for a month. So instead of I buying a complete apartment of 50 lakhs, what I can do, I can just take one flat for rent, and I will just have to pay for that particular flat which I have took on the rent. And when I will leave that flat, I don't have to pay. So only for that duration of the time when I'm utilizing that flat, only for that duration I have to pay. So I can take it on rent. That's how the renting market works. Same thing may work over here as well. Okay, so there are a lot of companies who are offering you these kind of hardware, okay, these kind of services on rent. Okay, so we have different cloud providers. These are called as cloud providers. Cloud providers. Okay, some pioneer over here is AWS is one of them. Azure is one of them. GCP is one of them. IBM is one of them. Okay, Alibaba is one of them. So these are some top cloud providers available in the market. What they are saying that instead of you configuring your entire data center, instead of you take care of 24/7 electricity, instead of you take care of cooling, instead of you take care of the hardware upgrade, give all this responsibility to me and just pay me a subscription fee. So for only that much amount of resources you have occupied, you will have to pay me. Okay. So let's say in this particular training, we are going to use AWS. AWS has the largest market share and all these public cloud providers. So I am going to buy AWS cloud, and I am going to ask in my AWS cloud that can you please give me, let's say, can you please give me 16 GB of RAM? Okay. And can you please give me 4 core CPU? So AWS will give me it, and then I can launch my application in top of it. And let's say if I got viral, I need more hardware, I don't have to worry. I can again request AWS, can you please give me 256 GB of RAM? I want it. So AWS can give you this much RAM, this much resources on the fly. Okay, you don't have to worry. Okay, so if you got more load, you can make it work with these public cloud providers like AWS or Azure or GCP. Or let's take a scenario, you have released your application, you have expected that I will create one operating system where I will take hardware of 256 GB RAM and multiple, let's say, 16 core CPU and all you took, but no one went or no one came to your website, no one came to your application idea, no one loved your idea. In that case, you can again release these hardware. You can say AWS, I took this hardware on rent from you for 1 hour, and then I notice that my application, my startup idea is not working that well. I will have to work more on it. So you can release it. You can say, AWS, can you take all these resources back? So AWS will take it back, and you will have to only pay for the 1 hour where you have utilized it. So only as per your usage you have to pay. Okay. So you are not creating or buying this hardware by yourself. You are taking this hardware on rent from these cloud providers. Okay. And these cloud providers have already set up, okay, already they have set up the entire, you can say, data centers for you. We are going to use these data centers. Okay, so let's learn about these cloud providers, especially AWS, in our today's class. And because once we get this infrastructure, once we get this hardware, then only I will be able to run my application. So that is the basic requirement. So I will go back to internet, and here you can search for AWS Global Infrastructure Network. So AWS had the money, you can say. That's why they have set up their data center, okay, across the globe. Okay, so if I just take a screenshot over here, and if I just create one more diagram. So guys, we are right now learning these things conceptually just for day number 1. Once you know these things, we will proceed with the practical. Okay. So now let's learn about AWS Cloud, what AWS Cloud is going to do for us. So AWS did one thing. Across the globe, they have set up their own data centers, you can say. So you can see in America, in Europe, in India also, they have in Mumbai and they have in Hyderabad right now. So in Mumbai, what they did, in Mumbai, they have set up one of the AWS region, you can say. Okay. So in Mumbai, they have bought some land from the government, you can say. And then in that particular land, they have created multiple data centers where they have put all of their hardware. So let's say this is my Mumbai region. Let's imagine this is my Mumbai region. Okay. Here they have created a multiple availability zone. These are called as availability zone, AZ in short form. In case of Mumbai, they have created 3 availability zone. Why 3? We will discuss about it in a minute. And each availability zone has one or more than one data centers. Okay, data centers. Data centers. Data centers are the one where your hardware devices will be kept. All your hardware devices, networking, electricity, everything will be done in the data centers. So what they did, they have already bought a huge amount of hardware, and they have already set up this hardware in the Mumbai region. Similarly, they did in Australia, they did in Africa, they did in America, and you can see they have did in multiple places. Okay, so many regions they have created, they have distributed. Okay, so that whosoever is going to use or take these hardware on rent from AWS, they can do it as per their locality. Let's say I am someone who is creating a website only for Indian people. Okay, so in that case, I will put my website or put my application only on a data center of Mumbai, so that my user will be able to quickly get my data. Because if I'm using a data center of America, let's say, okay, if I'm using a data center of America, it means my application is running on America behind the scene. And if my consumer who is sitting in Delhi, he wanted to use my application, so he will go back to America, and from America he will load the entire data, which will cause some network latency over here. That's why what your different companies does, as per their consumer base, they decide what exactly or which exactly data center, which exactly region they have to use. In our case, let's say we are going to use Mumbai region. Okay, so in Mumbai region, they have divided this region into multiple availability zone, and each availability zone has one or more than one data centers. Okay, and in these data centers, we have all the hardware. Now, why they have created multiple availability zone? Because it may be a scenario that you are using Amazon, and Amazon is giving you best security in this world. They are giving you the best kind of performance in this world. They are giving you best kind of service in this world, because Amazon is a known organization. You can see a lot of companies, Netflix, even Hotstar, even your Amazon Prime, all of these behind the scene are using AWS servers behind. Okay, so even Netflix uses Amazon AWS server. Why? Because Netflix is saying that my main goal is to create some good movies and web series, right? That should be the goal of Netflix. Okay. Their goal should not be to manage the entire infrastructure, because managing infrastructure involves so many things. So Netflix is saying that I am going to focus on my main goal. My main goal is to create good movies, okay, to create a good Netflix web application. Okay, that is my main goal. Everything about data centers, everything about hardware will be taken care by AWS. I'm taking it on rent and I will pay the rent. That's it. Okay. So here also we have multiple availability zone. So let's say Netflix is using Mumbai for their data centers. In Mumbai, they are storing all of their data. Let's say here they are storing their data. Some of the hardware they are storing their data. But it may happen, very rare, but it may happen that some earthquake happened in Mumbai, and because of this earthquake or tsunami or some physical or climate disaster, the entire availability zone is down. The entire data center is not working because a tsunami will happen, if earthquake will happen, or some other situation will happen, cyclone will happen. It is not in control of anyone, right? So this climatic situation is not in control of AWS as well. So AWS is giving you a guarantee that their servers will be always running, but it may happen some climatic situation happen, may cause a small downtime. Okay, so in that case, how can we manage it? So here, what AWS have done, they have created multiple availability zone in Mumbai, and each availability zone is almost 200 to 300 kilometer apart from each other. 200 to 300 kilometer apart. And there's a high chance if some climatic situation happen in Mumbai, it should not happen, but let's say if it happened, then in that case, it may happen when my first availability zone is currently being impacted. All the services, all the hardware running on my availabilities, this first availability zone is not working right now because of this climatic situation. In that case, whosoever would be running their servers in availability zone, first availability zone, then those website will not be available at that point of time. Those website will have a downtime, and no company want to have a downtime. Okay, because of this physical disaster. That's why what company usually do. Company distribute their workload. So if I'm on Netflix, what I will do, I will launch one copy of my Netflix application in Mumbai availability zone 1A, one copy of my Netflix application in Mumbai 1B, and one copy of my Netflix application in 1C. And let's say one copy I will run, let's say somewhere in Australia. So now I'm running 4 copies of my application. Why? Because if something happened to my first availability zone, a particular place, some climatic situation happened, earthquake happened, and that is currently down, I don't have to worry. My still other copies are working fine. They are untouched because these availability zones are almost 200 to 300 kilometers apart from each other. And there's a high chance if something happened to a particular place after 200 kilometers, it should not happen, right? So there's a high chance. Okay, that's why they have created multiple availability zone in a particular region. This is called as AWS region. Mumbai is one of the region. Hyderabad is one of the region. Similarly, in Australia also they have multiple regions which are created. Okay, so in these regions, AWS have already set up all the hardwares for you. We are going to request AWS, and then we are going to ask AWS that can you please give me these resources? I wanna utilize them. Okay, so that's what we will be doing. So we are going to use AWS Cloud, and in the AWS Cloud, we are going to get all the hardware. How to use AWS Cloud, we'll see in today's class in some way. So let's say we got the hardware from AWS. This part is now done. But how will I create operating system? And we have different kind of operating system available in the current world. Okay, we have Windows, we have Linux, we have Mac, so many different operating systems are available. So which operating system should I use for running my server? So what you will see in real world, if I again just draw one more diagram. Okay. So let's say here I have to choose which operating system I should use over here. I may use Windows. Okay. I can use Linux and I can use Mac as well. The problem with the Windows is not open source. So I can't see the source code, how exactly Windows is working behind the scene. Okay. So it is not open source. The source code of Windows is with the Microsoft guys. Okay. They have the source code. We are just using Windows. So Windows is good for those scenarios where you wanted to do some general tasks. Let's say you wanted to watch some movie, you wanted to use Paint, you wanted to use browser. For simple tasks, Windows is good. Okay. And the second thing is Windows is also very heavy. Okay. You will face some performance issues as well in Windows. You can't do much customization in Windows. Okay. Customization also, if you will try to do in Windows, you will not be able to do it. Okay. and then Windows may crash at any point of time. So they are not that much stable. Okay. A lot of issues are there with the Windows. Okay. That's why what we usually do in our real world, we usually use Linux operating system. Why Linux? Because Linux is one of the open source operating system. Open source operating system means you have the source code of Linux over here. Then Linux is very lightweight. Very lightweight. Linux is very lightweight. Okay. Linux is also very stable operating system because it is very important for you. You are going to launch your application in top of an operating system. Okay. If your operating system itself is not stable, in that case, obviously your application will crash. So you have to make sure whatever operating system you are using, that operating system is stable. That operating system is very lightweight. Okay. That operating system provides you the best kind of security over here. And because it is open source, so you can also do a lot of customization over here in this operating system. So as per your requirement, as per your choice of your application, if your application is a gaming application, so you will need you will need to maintain or manage your hardware in a different way. If your application is a normal web application, you will need to maintain your hardware in a different way. So as per your application, you wanted to customize your operating system. Okay. In case of Linux, it is open source, so you have a space for customizing it as per your requirement. Okay. And Linux is best suited for creating and running jobs, long running jobs. If you have some long running jobs, because your servers will be running 24/7. So Linux is good for that. Okay. That's why in this training, we will be using Linux operating system. Okay. So Linux is open source. Okay. If you just go back to the internet and search who is the father of Linux operating system, so you will see Linux to world. He is the father. Okay. So he's the guy who has invented, you can say, Linux, and then he made it open source. Okay. So you will see that Linux works on open source principle. Okay. Linux also provide you best kind of security, best kind of customization. Okay. It is very lightweight and it is suitable for creating long running jobs. In our case, it will be suitable for running our servers. Okay. So Linux will match all our requirement. That's why we are going to use Linux operating system. So Windows or Mac, we will use only for our day-to-day job where we wanted to serve network, internet. We want to watch some normal movies and all. Mac is good. But if you want to set up your own server, Linux is the best choice. Okay. So we are going to use Linux operating system over here. Okay. Linux kernel basically we are going to use. And because it was open source. So what different companies have done, okay, different companies have done, they took this open source code and in top of this open source code, okay, these companies have added some of their own customization, you can say. Okay. And then after adding this customization, they have started selling it with their own name. These are called Linux distribution. So we have different Linux distribution available. What they are doing, they are taking this open source code of Linux kernel as a base. And in top of this Linux open source kernel, they are adding some of their own custom features, you can say. And then they are bundling it up and they are selling it as their own distribution. So we have so many distribution for Linux available. You would have heard about Ubuntu. You would have heard about Red Hat. Okay, or Kali. Okay. So a lot of Linux distributions are available in the market. Each of these distributions are created for different kind of use cases. Like Ubuntu and Red Hat is usually created for maintaining your running your servers. Okay, so usually Ubuntu and Red Hat is mainly used for running your servers, and Kali is mainly made for those cases where you wanted to perform some kind of hacking, some kind of cracking kind of job where you wanted to have more access over there. So Kali provide you that kind of customized settings, that kind of customized software. If you want to create your own Linux distribution, you can do that. What you can do, you can take the open source code of this Linux kernel. For that, you should have a knowledge of Linux kernel. Okay. If you have that knowledge, in top of it, you can add your own customization. Let's say I wanted to create my own operating system. Okay. And I will take this open source as a base. In top of it, I will add, let's say, all the customization which is required usually for gaming, for, let's say, running the gaming application. Then I will bundle this up and I will start calling it as Sudhanshu's operating system. And whosoever will install this operating system, they will have all the support for gaming and other stuffs. So for a specific use case, you can set up your or create your own Linux distribution. These are your Linux distribution which has been created. Linux distribution. Okay, so there are hundreds of Linux distribution available in the market. Linux is the open source kernel. What these companies have done, they took this open source kernel, in top of it, they have added their own features, customization, and they started selling it with their own name. Okay, that's what they are doing. In this particular training, we are going to use that. Okay. Why Red Hat? Because Red Hat provide you the enterprise level support. Red Hat is best suited for creating the servers. Red Hat is very much stable. They have a very great community support, and they are very much good with the security as well. A lot of customization they provide you for security changes if you wanted to do. So Red Hat, or you can use Ubuntu as well. But in this training, I will be mainly using Red Hat. I've worked with Red Hat a lot. So and that is used by most of the companies, okay, as the main Linux operating system. In top of the Red Hat Linux operating system, they create, they launch their applications. Okay, so we will be using that Linux over here. So we will first get our hardware from AWS cloud, because we don't want to set up our own data center. We don't want to manage our own hardware. So we will get the hardware from AWS cloud. Once we have the hardware, in top of that hardware, we are going to set up a Linux operating system. And once our Linux operating system is being set up, in top of it, we are going to start or run our application. That is the final agenda. So guys, till here, everything is clear or not? You can ask me your queries. So Mukesh, you are saying anyone familiar with cloud computing? Yes, so this is what we are doing in cloud computing, right? We are using AWS cloud over here. So whatever resources, everything, whatever we are doing over here will be behind the scene done on AWS servers. Remotely, we are using AWS resources over here. So whatever application I will be running, it will not be running in my physical laptop. It will be running over over the internet on cloud, AWS infrastructure, AWS data centers, you can say. Okay, that is fine, Vibhor Shukla. If you use something else, that is fine. Yes. So what, Sarad, that's a very good point you have added. So what Ubuntu and Red Hat does, so because they took, you can see here, they took the base, where is my diagram? Yeah, they took this open source code as the base, and in top of it, they have added their own customization. Okay, so it is their main responsibility, because they have took something from the open source community, so they should also give something to the open source community. That's why what Red Hat or Ubuntu is doing, they have different kind of Linux available. Okay, if any one of you is aware about Fedora, CentOS, okay, or anyone is aware about Red Hat Enterprise Linux. Okay, so what happened in Red Hat Enterprise Linux? In Red Hat Enterprise Linux, it is as per the subscription. So whosoever company will be using Red Hat Enterprise Linux, they will have to pay for it. They will have to pay the subscription fee, and in return, they will get the support from the Red Hat team. They will get some more customization, some more help. But because Red Hat took something from the open source, so they have to also give something to the open source. They have to return something to open source. So they also release one open source version for Fedora, okay, CentOS, and they make it open source. But usually, all the companies, what you see, who are using this Linux operating system, because let's say if I'm Unilever. So for me, it is very important, if something happened to my Linux operating system, there should be a technical guy who can help you to debug it. That's why usually your companies go with the enterprise license, because with that license they get the support as well. But if you want to use it for your practice purpose, for your development purpose, you can go with the open source version of it. So in this training also, we are going to use the open source version. We are not going to buy any kind of subscription. Usually companies will be doing that. Okay. Okay. So did we any other? No, these are like when we will be using AWS cloud, Manu. So AWS cloud will provide us a free tier. So if you are new to AWS Cloud will provide you 1 year of free services, where you can use AWS resources for free. You don't have to pay anything, but they have a limit. You should not go beyond that limit. If you go beyond that limit, they will start charging you. Otherwise, it will be free. We'll discuss about that as well. How to deploy in AWS, we will discuss. We'll see that practically. Okay, so you don't have to worry, Uday, if you don't have Linux. I will show you everything. I will show you. Don't worry. Okay. Okay, so again, Kishle, if you wanted to download Linux by Red Hat, you will have to download one of the ISO file of Linux, and then you will need a VirtualBox in your system, and then you can set up it. Again, what is VirtualBox? What is Linux? I don't want to, what is VirtualBox and ISO file? I will not go to that direction right now. Give me some time. I will explain you that as well. Okay. So we'll discuss how this Linux operating system can be created, how it can be used in your local system as well as in your cloud. Both things we will see. Okay, we haven't started any practical yet. We are just learning the theories right now. Okay, we'll see how it can be done. So now, guys, I hope you are clear. We will get the hardware from AWS. In top of that hardware, we will set up the operating system. Once we have our operating system been set up, then we will deploy our application, which is being developed by our developers. Okay, so let's go to AWS Cloud and let's see practically how AWS Cloud work. So if you wanted to use AWS Cloud, you have to go back here and you even search AWS create account. So you will have to create your AWS account, and AWS will provide you 12 months of free tier limit where you will be able to use most of the AWS services for free of cost. You don't have to pay anything. So go to create an AWS account, go to this website. Okay. And in my case, I'm getting a login button. But let me go to incognito tab and let me just say AWS create account. I already have my account ready. That's why they will ask me to log in over here. So you can go with AWS free tier. Okay, so this free tier will help you to practice AWS cloud, and AWS will not charge you. Okay, so you can click on create a free account. Click over here. Once you will click, they will ask you to give your email ID, and then they will ask you to give your any account name as well. Okay, whatever you want. Okay, after this you can verify your email address. When you will click on verify email address, you will get a OTP from AWS in your email ID. Once you got the OTP, you will have to give that OTP, and then you will be able to verify your email address. Once you have verified your email address, the next step will be AWS will ask you to provide your credit card or debit card detail. Okay, what are these details? So AWS will say that you are using my services, you will also have to pay for it. But because we are new to it, so you can say that I am new to it. I'm not a company. I'm not using it for enterprise purpose. I'm just using it for learning purpose. So in that case, still AWS will have to validate you. That's why AWS will ask you for your credit card or your debit card. In debit card, they support Visa debit card. In credit card, I think they support all the credit card available over here. Few times back, I saw that debit card they don't support Rupee debit card, but they support Visa debit card. So you can again check whether they support Rupee debit card or not. So when you will give your debit card information, they will detect some rupees from your account. Let's say 1 rupees from your account. Why they are doing it? Just to make sure that you have a valid card. And once they will detect it, after some time, they will also return this money to you. So this money they have deducted from your card only for validating whether you have a valid card or not. Only for validating your identity, they have asked you to provide your credit card or debit card information. They will detect 1 or 2 rupees or 5 or 10 rupees, and then after some days they will also return you back, and they will say that your account is properly being configured, and now you can use your services. And they will also by default enable your AWS free tier. In free tier, for next 1 year, they will not ask you for any of the charges. You can use AWS services for free. You have to be in limit, but you can use it for free. So once you perform these many steps, you can do it after today's class. You can give your information, click on the verify email address. They will ask you rest of the details. You can give those details over here, and then your account will be created. Okay, I'm not showing you right now because I already have the account created. It's very straightforward. Just give an email ID, give your credit card name, and that's it. Your account, credit card information, and your account is completed. Once your account is completed, you can go back to AWS and you can sign in to AWS Cloud. Okay. When you will try to sign into AWS Cloud, they will ask you for your credentials which you have set up. In my case, my credentials was already present, so that's why they have directly open it. They will show in the right side what is your username. In my case, my username is Sudhanshu. They are telling me this is your username, your account. You have logged into your account right now, and then they are saying AWS offers more than 200 services. So for all the different use cases, AWS have a service created. Okay. So if you check, if you want to work in blockchain, AWS have a service for that. If you wanted to work for databases, AWS have services for that. For that. If you wanted to work for game development or IoT, AWS have services for that. If you want to work for machine learning, you want to train your own machine learning model, you want to use some of the existing machine learning model, AI model, AWS have services for that. Okay. AWS have services for media services, AWS have services for robotics, satellite. So for all the domain, AWS have some kind of services pre-created, which you can just use it. You just have to pay for the rent, for the usage which you have done. Okay, so they have more than 200 services. We are not in AWS class, so we will not discuss about all the services. We are only going to learn about some important services in our training. Okay, in this case, we are going to learn about compute and we are going to learn about EC2. EC2 service. That is the first service we are going to learn today. What this will do, EC2 will do, this EC2 will help me to create an operating system for us. Okay. Once this operating system is created, in top of this operating system, I can run my application. So I wanted to create, okay, I wanted to create my operating system. In that case, I will use this AWS EC2 service. Okay. Once I will use it, behind the scene, what will happen in your AWS Mumbai region, because I will be using Mumbai. In this data center, one operating system will be created for you. And this data center, this operating system is currently present physically in Mumbai. And I don't have to go to Mumbai to use it. I will be doing a remote login to this operating system. I will be doing a remote login to this operating system. I will be sitting in my local laptop, and on via internet, I will be able to log into my operating system, and I will be able to run commands in my operating system. I will be able to install softwares in my operating system. Whatever I want, I can do that. So my operating system will be running in my data center in Mumbai. I will be using it via doing a remote log. So I don't have to physically go to Mumbai. Okay. I will be doing a remote log. Okay. Now we have to understand one more very important concept, and that concept is the base of your cloud computing. That concept gave the birth to the cloud computing. Okay, what is that concept? So guys, the thing is, whenever you wanted to run any application, by now you are clear that you need to have a hardware. Okay, and then in top of that hardware, you have to set up one operating system, and then you can create one application. So in earlier time, what was happening? Whenever you wanted to deploy your application, we use bare metal. Okay, what is bare metal means? You will go to market. From the market, you will buy this hardware. And in top of this hardware, physical hardware, you are going to install your operating system, and then you will run your application. Okay, let's say I am Amazon. Okay, I'm Amazon over here. Let's take an example of Amazon shopping. Amazon shopping website. So you will see that Amazon shopping website provides so many different services. Okay, so many different features they provide over here. Okay, so if you go back to Amazon shopping website, let's take an example of Amazon shopping right now. We have already took an example of Instagram and Zomato and all. So if you ever go to Amazon.com, you can see they have so many services, so many features you can say. One of the features in Amazon, you will see that we have a search button over here, search icon over here, where I can search for the product. Whatever product I will write, I will be able to search it. You can see search is happening. Then they have one of the feature where I can see all the items which are added in my cart over here. Then I have a feature over here where I can let's say check how many orders I have made till now in Amazon, and I can see how many orders I have returned till now. Then here you have a feature that is catalog feature where you can see all of your products. Okay, you can select this product, you can move this product to your cart, and then you can buy this product as well. You can click on add to cart and you can buy it. When you will click on the buy button, what will happen? This product will you will have to pay for this product. One payment page will be open, and then you will pay for it, and then you have successfully ordered this particular product. Okay, so you can see in Amazon there are so many different features which they are offering. One of the features in Amazon could be that here they are providing you authentication. you can authenticate to your AWS account first of all. So you have to first sign in over here. Right now, I have not been signed in. That's why my account is not being added over here. Once I will do a sign in, I will be able to see my past orders and my other preferences. Then you will see that Amazon also provide you some kind of advertisement. They keep on showing you some of the advertisement over here. Okay. So there are so many features which Amazon is providing. Okay. One of the feature could be, as I discussed, cart, where you can see your cart. Okay. One is your catalog, where you can see all the catalog. Then when one is authentication, where you can authenticate. One is the billing page, where you can pay your bills and all. And these days, Amazon also have a mini TV or something like that. In Amazon mobile application, we have a mini TV where you can watch some movies or web series. Okay. So there's one application which is offering us so many different features behind the scene. Same example you can take with Paytm as well. So Paytm offers you one of the feature for booking movie ticket. One of the feature for paying someone via UPI. They have a feature for booking flight tickets. Okay, so Paytm is one of the application, but that one application is offering us so many different kind of services. Okay, and usually what we want to run all these services. Okay, all these services which I have defined, or all these features which I have mentioned in different systems. Let's say here in my Amazon shopping case, what I'm doing, I'm running here my Amazon cart service. Here my Amazon cart service is running. Then I will have to buy one more operating system, one more hardware I will have to buy, and then in top of this, I will run here my catalog service. Okay. Then I will have one more hardware, one more operating system I will buy from the market, and then I will run my authentication service. Then I will buy one more hardware, and then let's say here I will run my operating system, and then here I will run my mini TV. Now, if someone is aware about this kind of architecture which I am discussing over here, this is called as microservices architecture, where if you have one application and that one application has so many features, so many small features, so many small services. Okay, so these small features we start calling it as microservice. Micro means small, service means service. So it is one of the small part of your Amazon shopping website. Amazon shopping is a bigger application. That bigger application has so many smaller microservices. Okay. Now, if you want to deploy them, I want to deploy them separately, independently, individually. So one of the way for deploying them independently, individually can be that I can buy 4 operating systems from the market. You can imagine I can buy 4 different laptops from the market, 4 different bare metal from the market. Okay, here each operating system will have their own set of hardware, and then in top of it, I can deploy my application. This is my application, catalog application, mini TV application, and then authentication application will be done. So here there is a problem with this particular setup. The problem is I had a bigger application. Okay, I had a bigger application. Okay, this bigger application I have divided into smaller microservices for a better management. Okay, and I want each of these microservices to be independent from each other, to be deployed independently from each other. So what I did, I bought 4 different operating systems. Okay, because I had to take care of their security, I had to take care of their scaling. Okay, let's take an example. Let's say Amazon has released a one Black Friday sale. Black Friday sale. Okay. Whenever Amazon will offer any kind of sale, let's say they are offering some discount. So suddenly there will be huge load on their Amazon servers. Okay. And usually people will be focusing on, let's say, catalog service, where they can see different kind of product, they can select the product, and they can do the billing. So let's say right now my here in this particular operating system, my card service is running. It is occupying only 70% of my RAM. It is occupying only 30% of my CPU, right? Here, my authentication service is running, it is occupying only 20% of my RAM and 30% of my CPU, for example. This one is occupying, let's say, 70% of my RAM. Okay, let me give a different value. 80% of my RAM and 20% of my CPU. But because there is a huge load on this particular service, catalog service, then here almost 99% of RAM is being utilized and almost 95% of CPU time is also being utilized. So in this case, what you will see, the other operating system are still in a better state, but this operating system is in a huge load. If you don't give more resources to this operating system, then this operating system will crash after some time. So here, what could be one of the solution? One of the solution here could be that I can go to the market and I can buy one more operating system. Okay, we just create a better diagram. I can again buy some hardware. I can buy one more operating system, and then in top of this operating system, I can run my catalog service. But this is not a good solution. Why? Because some of the resources which I have in which I have over here, it is currently underutilization. So a lot of underutilization problem we are facing over here. Okay, here let's say I'm not able to utilize 80% of my RAM. Only 20% of RAM I'm utilizing. But when I bought the hardware, I have paid the 100% amount for that hardware. So it is a loss for the company. So for company, it is a loss because company paid for the hardware and you are able to utilize only 20% of that hardware. So for 80% of the hardware is currently in the idle mode. That is a loss for you. You are paying for the electricity, but you are not utilizing it. Here, some of the hardware, some of the resources, some of the computing power was extra, but you are not able to share this computing power with your other operating system, which is in need. This was in need. So what you are doing, you are creating a separate operating system. This was an older way of creating the servers, guys, and it was very hard for companies to manage it. A lot of underutilization problem they were facing. A lot of hardware they were not able to utilize. And here we come up with a technology that has changed the entire picture. Entire all the companies everywhere you will see the this technology which is being used, and this technology is called as virtualization technology. Virtualization technology. What this virtualization technology does, it did a small change in the picture. Guys, again, don't draw anything in my screen, guys, please. There are so many things I can see being drawn over here. Okay. So please don't draw anything. Okay. So here, what we will do in this virtual technology, we will go to the market and we will buy the hardware. The same way we were doing earlier as well. Let's say in the hardware, I bought 20 GB of RAM and 4 core CPU, and then I have bought 10 terabytes of hard disk. This is some of the hardware which let's say I have bought, or I may have took this hardware on the rent as. Okay. So this is the hardware which we have created, which we have bought. Guys, by default, what happened? In top of one hardware, you can launch again, guys. Please don't draw anything over here. I will have to remove you, James. James, I will have to remove you from the meeting if you draw it again. Okay. Please don't draw, guys. Okay. So whenever we have an hardware, in top of that hardware, I can launch only one operating system at a time. Means in one hardware, you can launch only one operating system. That was a constraint earlier. But when this virtualization technology comes up in the picture, what happened? There's a tool which came in the picture that is called as hypervisor. Okay. With the help of this virtual technology, what you can do in top of a single hardware, you can now launch more than one operating system as well. And each of these operating system will be independent from each other. So now let's say I have launched 4 different operating systems. And each of these operating system are independent, means whatever I am doing in this operating system will not be visible to this operating system. Each one of them are independent from each other, completely independent. What kind of data I'm storing in this operating system will not be visible from this operating system. And you can also launch different kind of operating system as well. Like here, I may be running Windows. Here, I may be running Mac. Here, I may be running Linux, Red Hat, for example. Here, I may be running Ubuntu as well. So different kind of operating system may also be running. And each one of them are going to use the same hardware behind the scene. So this is called a shared hardware. Now this hardware is being shared with these multiple operating systems. How is it possible? Because of hypervisor. Why? Because your operating system only work with a single hardware. Like you can't share your hardware with multiple operating systems. So here what the hypervisor is doing, or what this virtualization technology is doing, they are creating the virtual representation of these hardware. Means virtual hard disk, you can say they are creating and they are attaching it with this particular system. So let's say this system is occupying only 5 GB of my RAM. This one is occupying 10 GB of the RAM. This one is occupying 3 GB of the RAM. Overall, 20 GB of the RAM they can occupy together. 10, 15, 16, and 18. And then this one, let's say, occupying 2 GB of the RAM. Now, let's say this particular system need more RAM. So I can remove some of the software running in this particular system. Let's say I will remove one of the software. Now it is occupying only 1 GB of RAM. So now this one can use 11 GB of RAM. So now each one of them are behind the scene using a shared hardware. They're using same hardware. Out of 10 terabytes of hard disk, let's say this one is using 1 terabytes of hard disk. This one is using 5 terabytes of hard disk. Okay. This one is using 2 terabytes of hard disk. Okay. And this one is also using 2 terabytes of hard disk. So all the resources, all the hardware now can be distributed or can be shared between them. Okay. And they will be able to utilize it. Okay. So now this is not a real operating system. This is called as virtual machine. Although they are behaving like a real operating system, but because we are using a virtualization technology over here, we have created a virtual representation of hardware over here. So this operating system, if you go to kernel of this operating system will still think that this operating system has been physically attached with 1 GB of RAM. This operating system will physically think that 1 GB of RAM has been attached to it, like a laptop. But in reality, this 1 GB of RAM is not attached to it. This 1 GB RAM is a virtual RAM which has been created from this bigger chunk. Okay, this bigger chunk. We have just took 1 GB of RAM, and that 1 GB of RAM we have attached to this particular operating system. And everything, like how exactly all this operating system between this operating system resources will be divided, will be taken care by your hypervisor. Okay, so this is creating your virtual machines. This is the one which will take care that all of them are independent of each other. Yes, Sarad, you are very correct that if we are doing underutilization, we can return that resources with AWS. I will come to that. Okay, we are coming to AWS part as in a minute. You will see how we can return it. Okay, the problem was when I was creating the older setup. In this setup, I was attaching one set of hardware to only one operating system at a time. Okay. And then now what we are doing, instead of launching our operating system directly on a hardware, we are using a layer of virtualization technology. Okay. Here we have a tool hypervisor. That hypervisor is the one which is helping you to create these multiple virtual representation of server. These are also called as your virtual machine, virtual servers, whatever name you want to give, you can give it. And this is a technology which has changed so much in the market that this technology gave the birth to the cloud computing. So virtualization technology is the one which gave the birth to the cloud computing. So now you will see how AWS work behind the scene. Okay. So what AWS does. Okay. So let's say I am currently one of the consumer of AWS, and let's say I need 2-core CPU and I need, let's say, 4 GB RAM. So what I will do, I will request AWS, can you provide me these resources? So what do you think? AWS will go to the market, will buy this physical hardware, will take this physical hardware to their data center, then will physically set up this everything for us, and then they will give it. No, they will not do it because it will take so much time. Okay. So what AWS is saying, AWS is doing one thing. They have already bought a bigger chunk of hardware from the market. Okay, let's say they have bought again let's say 900 GB of RAM, and then they have multiple core of CPU, petabytes of hard disk they have already bought and put in data center. These numbers are very less over here. In real world, the number is very huge. Okay, so these many hardwares AWS have already bought. So they are not going to market and buy the hardware whenever you will send your request. They are not doing this thing. They already have this hardware pre-bought, you can say. Then here behind the scene, they are using a technology which we discussed just now, virtualization technology. And that's why I'm saying this virtualization technology gave the birth to cloud computing. So this entire cloud computing is present because of this virtualization technology. Why? Because in this virtual technology, we have a way where we can share a single hardware with multiple operating systems. And that's what AWS is also doing behind the scene. So let's say in AWS Mumbai region, there would be hundreds and thousands and millions of users who will be who will have AWS account in Mumbai region and who will request for the resources. Let's say this is me, I am requesting for the resources. Let's say this is someone else who is requesting for the resources. Let's say this is you. Some of you are also trying to create one operating system in AWS and you are requesting, let's say as per your requirement, you are requesting, let's say 4 core of CPU and 8 GB of RAM. So a lot of people who are the users of AWS are requesting AWS about the resources. So AWS can't go to market and can't buy a bare metal, can't buy the hardware and attach to a particular operating system. It's not possible. So they have a hardware already been bought. Now they will use this version technology, and with this version technology, they are going to create one operating system for us, and this they will name it as virtual machine. They have a bigger chunk of hardware, but because I requested only for 2 core CPU and 4 GB RAM, so they will only give me 2 core CPU and 4 GB of RAM. Okay, that's it. And I have to only pay for this. And now AWS have millions of customers who are using their services. So let's say you are also parallelly asking AWS for your virtual machine. So AWS will also create one operating system. Now this operating system is not for my account. This operating system is for your account and where you have requested for 4 core CPU and 8 GB of RAM. So AWS will give it for you. And as I discussed, the basic concept of virtualization, each virtual machine, each operating system will be independent from each other. So whatever I am doing in my AWS account is you will not be able to see. And what you are doing in your AWS account, I will not be able to see because AWS is taking care of this entire security between them. Okay, so it may happen right now in AWS Mumbai region, there could be thousands of virtual machine running, which will be requested by different kind of users, different kind of consumers. And as per their request, their virtual machine is being initiated and they're only using a one part of the hardware. They are not using the entire hardware. They are only using a one small part of the hardware. So this hardware is now being shared between multiple virtual machines. That is a core concept between a cloud computing. Okay, same concept you want to relate with, let's say, a renting system as well. Let's say you are someone who wanted to have a, let's say, a home. So in that case, one way could be go back and buy the entire apartment or entire flat for you. Or the other way could be there could be some builder in your society, and what that builder can do, that builder can buy the entire apartment, and then in that apartment he can start sharing or selling all the flats which are present in that apartment, and you will have the key only for your flat. You will not be able to see the content of other one's flat because you have the key and the access only of your flat. That's what is happening over here. So AWS is creating the or buying the entire hardware pre-handy. Whenever you ask AWS to create an operating system for me, they just create one virtual machine for me, one virtual representation for me, okay, one virtual server for me, and this will be given to me. Okay, so what my virtual machine is using, same hardware your virtual machine will also be using if you are also using AWS cloud. But we will never be able to see each other data because AWS is taking care of the entire security part. Entire security between this virtual machine, AWS is taking care of. Okay, so AWS is doing nothing. AWS is like a builder who had the money, so they have already bought lot amount of hardware. They already set up this hardware in their data centers. What we are doing, we are just taking a chunk of that hardware, a small part of that hardware for our use cases. Okay, and that is the reason I will use this virtual machine. And once my work is done, I can terminate this virtual machine. I can remove this virtual machine. I can say AWS, my work is done. Please terminate this virtual machine. Please remove this virtual machine. As you will remove it, what will happen? These core of CPU and these GB of RAM which you are using is now been released, and these resources can now be used by someone else in the AWS cloud. Okay, so that's why AWS pricing will also change as per the demand of the computing power. AWS pricing will change, will keep on changing. Okay, because if the demand is high, AWS will obviously charge you more. Okay, that's how the entire things work. If you go back to the internet and see more about virtualization technology. Okay, technology. So you will see virtualization is a technology that allows multiple virtual machines to run on a single physical machine. Single physical machine means single hardware. It creates a virtual environment. Whenever you see a term virtual, means it is not real, but it is behaving like a real environment. So these operating system which I am creating over here, these are not real operating systems. These are not like laptop. running on a single hardware. They are behaving like an operating system, but they are not real. That's why we usually call them as virtual machine, okay? Virtual operating system. It creates a virtual environment that emulates the functionality of the physical hardware. Okay, that's what I was saying. So if you buy a laptop with 8 GB of RAM and 4 core of CPU, okay, same kind of feeling it will give to this virtual machine as well. It will give you a feeling that you have a 4 core of CPU and 8 GB of RAM physically attached, but behind the scene you are using a shared hardware from this bigger chunk. Okay, so that's what they are doing, enabling efficient resource utilization and cost saving. And that's why we call it as cost saving, because now the resources is being distributed among all of the virtual machine. If one of the virtual machine don't require much resources, this resources can be shared with other virtual machine. So whatever under utilization problem we were facing is now being solved via this virtualization technology. Okay, so virtualization technology will help us for resource sharing. Okay, it creates a layer of abstraction between the underlying hardware and the virtual machines, allowing them to share resources like CPU, memory, and storage. That's what we discussed. Okay, this will provide you cost reduction, improve resource utilization, and entire cloud computing is working behind the scene on this technology, virtual technology. So when this virtual technology comes up in the picture, it gave the birth for the cloud computing. Okay, so you will see the birth of cloud computing happens because of virtualization. Because in cloud computing, what you are doing, you are just using a chunk of the hardware. So your cloud provider have set up a bigger chunk, bigger amount of hardware. You are only using a chunk of hardware. That's why you are only paying for that particular part. And once you will release that hardware, once you will release your watch operating system, you will say, I don't want to use it anymore. So AWS will stop charging you. Because once you will release that hardware, now that hardware can be shared with someone else, someone other account. Okay, so AWS will keep on doing it. Same thing happens in renting as well. You have to only pay for your flat till the time you are you are uh, uh, you are living there. As you will leave this, you will say, I don't want to use it anymore. This flat will be shared with someone else. This flat will be given to someone else, and then they will be able to use it. Okay. Similar kind of concept is being used. If you say a good example, virtualization is a technology that enables the creation of virtual environment from a single physical machine with single physical hardware, allowing you to more efficient use of resources by distributing them across computing environment. Okay. So here, if you go down, IBM have some great documentation. They will show you benefits of virtualization, resource efficiency, easier management. Okay, and then underutilization problem will also be solved. Okay, and if you see, it is also cost effectiveness. Okay, because you're only paying for the amount of resources you are utilizing. Okay, so in case of AWS, I'm only paying for the amount of resources which I'm utilizing. So it's cost effective for me at least. Okay, that's what we can see. And hypervisor is the main tool which makes all these things work for you behind the scene. Okay. So, sir, you are saying that you want to deploy a microservice on different virtual servers on same hardware. Um, okay. So, Sarad, like when I will create a virtual machine in AWS, whatever operating system I will create in AWS, they will be eventually your virtual servers only. They will be your virtual machines only. In top of that virtual machines, you can deploy your microservices. Okay, you can run your microservices. And each of these virtual machines you can create multiple virtual machine as well in your AWS cloud. And each of your virtual machine will be independent from each. Okay. So yes, like AWS assign you these virtual servers okay into your account. Like if I go to my AWS account, and in AWS account I can see how many virtual machines are running right now. So you will see they are saying that no virtual machine is right now running in your account. No running. But right now, if you go to, if you also have AWS cloud, if you also go to Mumbai, you may see that you would have launched some of the virtual machines. Those virtual machines, because are attached to your account, only you will be able to see it. I will not be able to see it. So here, right now in the Mumbai region, there may be thousands of virtual machines running. But because I am not the owner of this virtual machine, I am not able to see. Here, I will be able to see only those virtual machines which I have requested. So each of these virtual machine which AWS will give me, AWS will attach them with a particular AWS account. Only that AWS account owner will be able to see. Okay, same thing in your apartment also. Okay, your apartment guy will only give you the key of your particular flat, so that you will not be able to see the other flat. You can't go to other flat because you don't have the key, because it is attached only to your name, your account. Similarly, here also, for in my account, I haven't requested for any virtual machine yet. So none of them is running right. But once I will request, I will start seeing them over here. Okay. So I hope it is clear for you, sir. Anyone else have any issues? Okay. Yes, we can deploy our services on different ports as well. We will discuss about it in the containerization class. So we have one more technology that come after virtualization, you can say, that will again make a lot of things more easy, more clear for us, and that is containerization technology. Docker is one of the tool. We'll discuss about that in our upcoming class. Like how can we run multiple services in the same operating system? And how can we make sure each of these services are independent from each other? So for that, you will have to use Docker. Okay. Okay. So guys, now let's see how can I request my AWS to create a virtual machine for me. Okay. So I will go back to my AWS account. Similarly, you guys can also go to your AWS account once it will be set up or created for you. We have an option over here to launch instance. I will click over here, launch instance means I want to launch a virtual machine. Okay. And then here I will have to give a name to virtual machine. I can give any name as per my requirement. I will say GFG workshop. Okay. Sorry. GF. Okay. GFG workshop. Then here we will define, okay, which kind of image you want to use. Okay. This is very important. So guys, if you have remembered, if you would have ever set up your Windows operating system, you will see that whenever you want to set up your Windows operating system, they will ask you to first download one image file, one ISO file. Okay, that ISO file have the entire information about your Windows operating system, how Windows operating system work, what are default softwares available in the Windows operating system, what are components are there in the Windows operating system. Similarly, for all the different kind of operating system, there is one image created. And here we have to select which kind of operating system I want to create over here. I want to create Ubuntu, Windows. I can create Windows as well. Mac as well I can create without any cost. I can create Mac as well. Red Hat I can create. Okay, I can create any one. But right now I'm going to use Amazon Linux. So Linux is one of the open source kernel, you can say. And there are a lot of people, what they did, they took this kernel and top of this kernel, they have put their own customization and then they start selling it as their own distribution. Similarly, what Amazon guys have done, they also took Linux as one of the base, open source as the base. In top of it, they have set up some of their own customized softwares, and now they are calling it as Amazon Linux. And this Amazon Linux is being set up by taking Red Hat as a base. That's why you will see in Amazon Linux, whatever Red Hat commands I can use, same command will be applicable in Amazon Linux as well. I'm using Amazon Linux over here because Amazon Linux will give you a very user-friendly interface for utilizing it. So for our initial classes, we will be using Amazon Linux over here. Okay. So Amazon Linux will help you to run all the Red Hat Linux commands. So don't worry. So in Red Hat Linux, we have Fedora. So Amazon Linux took Fedora as one of the base, and then they have set up their own customization. So here I will be able to utilize it. That is one of the image which we are using. So I want to launch here one operating system. Then I'm saying I don't want to launch Mac OS or Ubuntu or Windows. I want to use Amazon Linux OS. Then I will give the architecture, again 64-bit architecture we are using. Now in the instance type section, we have to define, okay, what kind of instance I would like to use. So here I will have to decide as per my requirement how much RAM or CPU I want. So you can see by default they are saying telling me T2.micro. T2.micro comes under free tier, means whenever you will create your AWS account for the first time, if you use T2.micro, they are not going to charge you any cost. Okay, they have a limit. They have a limit that if you are using AWS EC2 instance and you are using T2.micro and T2.micro, they will give you only 1 GB of RAM and 1 core of CPU. And they are saying that they will charge this much amount, 0.0124 USD per hour, which is very less. But because you are using a free tier account, you will not have to pay this. Okay, so you will not have to pay this until you are in a free limit. So if you want to see what is the limit, you can check EC2 AWS free tier limits. So they have a limit that if you use this AWS EC2 instance, and if you use it only for 750 hours per month, then they will not charge you. If you use this AWS EC2 instance for more than 750 hours per month, they will start charging. So for testing and development purpose, for learning purpose, 750 hours is enough. So if you run your EC2 instance with T2.micro, then they will not charge. Because in T2.micro, they are giving you only 1 GB of RAM and 1 core CPU, which is very limited, which you can use for practice purpose. But if you're a company, you want more resources. So as I will scroll down, you can see we have so many instance types available. Here they are giving me 8 GB of RAM and 4 core of CPU. And here the charge will be more, 0.2 USD per hour. If I scroll down, then here you can see they are giving me 128 GB of RAM and 64 core of CPU, and the charge is almost $1 per hour. Okay, almost $1.5 per hour. So let's say if you're a company and you are going to run some important task over here, and let's say you need more resources. Okay, let's say you need 144 GB of RAM and 72 core of CPU. Okay, so you can select this one. In that case, your company will have to pay for this amount. They are saying that for if you use it for 1 hour, I will charge you $3, which is very less in comparison to if you go to market and buy this hardware by yourself. If you buy 144 GB of RAM and 72 core of CPU, a big amount of upfront cost you will have to pay. But because I'm taking it on rent, I will have to only pay small price, $3 per hour. So I have to pay only $3 for an hour. If I use it for 10 hours, I will have to pay $30. Okay, that's how it is going to be. So your company will decide as per their requirement. We are currently in learning purpose, so we will go with T2.micro, where you will not have to pay anything. They will give you only 1 GB RAM, 1 core CPU, which will be enough for our initial discussion. Then, guys, this virtual machine, this operating system will be created in your AWS infrastructure, okay, in Mumbai region somewhere. How will I be able to connect to this EC2 instance? So this is the operating system, right, which we are creating. This operating system will be created in AWS data center. And right now, I am present in my local laptop. I am not in Mumbai. AWS data center is in Mumbai right now. If you go back to my screen, you will see I am currently connected to Mumbai. If you wanted to change your data center, you want to create this virtual machine on North Virginia, California, Seoul, or somewhere else, you can select the exact reason. But right now, I have selected Mumbai. So this particular virtual machine will be created in my Mumbai region. Okay. So in Mumbai region also, I don't have to go there and manually check my operating system. I'm going to do a remote login to my operating system. Remote login. And if you want to do a remote login, you will also have to prove your identity. That's why here we have to set some kind of key as well, some kind of password as well. And usually setting up the password is not a best way of security. That's why in Linux, usually we create key pairs over here. So they are asking me to create a key pair. Click on the create a new key pair. Okay, give any name GFG 33, sorry, GFG workshop. And then I am going to use RSA algorithm to create a key pair. Click on create key pair. One key will be downloaded in your system. So what we will see, if anyone is aware about cryptography, so they have downloaded one private key in my system. And via this private key, I will be proving my identity as I proceed ahead. So as I proceed ahead, I will have to prove my identity. So this key will be used for that, for authentication purpose. Okay. So I have attached the key as well. Now we can decide on network settings. Right now I'm going with all the default settings over here. Okay. And then I will decide how many storage do you want? How much hard disk do you want? So behind the scene, they are going to provide one SSD hard disk, one of the SSD storage, and they are going to provide me 8 GB of SSD storage right now, which will be enough. If you will go beyond that, you will have to pay. So right now we are in the free tier. In free tier, if you will take the storage up to 30 GB, you will not have to pay anything. If you go beyond 30 GB, you will have to start paying for it. Okay. So I selected 8 GB, which comes under free tier. So they will create one SSD hard disk of 8 GB and they will attach it to our operating system. I will click on the launch instance, and what will happen? I have sent a request to AWS to launch a virtual machine for me. And what you will see in a minute, AWS will launch the virtual machine for me, and you can see it is ready also. So fast, right? Why so fast? Because they had this underlying hardware pre-set up. They had to only do one thing. They already had the hardware. They just had to create this virtual machine, and they have created it for us, and they have attached this hardware to us, which we can utilize. Okay. Once this has been created, now you can connect with your virtual machine, your operating system. Okay, so you can refresh. It will show you that this is currently in the running state. If you want to connect, we have two ways. One you can connect it from your terminal as well. So you can click on the connect icon, and here we are going to use SSH protocol for connecting to our instance. So we are going to use SSH protocol means to connect to my this remote system. I will be using SSH protocol. Okay. And what they are saying, they are giving me one of the command. I will copy this command and I can go to my terminal command prompt. Okay. In the command prompt, I can go to the location where my key file is being downloaded. So I will go to my downloads folder. I can see, guys, you have drawn so many things on my screen. Okay. So it is very fine for now. So I went to my downloads folder. Now I will run this command. What I will do SSH to my instance. They are saying, do you want to connect? I'm saying, yes, I want to connect. You can see now I have connected to my AWS virtual machine and I got a terminal of it. Okay. So guys, in Linux, what you will see that Linux will mostly provide you CLI to communicate. Okay. So whenever you have an operating system, if you want to communicate with the operating system, they provide you multiple ways. One is they will provide you a very user-friendly interface. Okay, user-friendly interface. Like in case of Windows, you can see they have provided me a UI over here which I can use. Okay, user-friendly interface where I can click with the mouse and I can use it. And they also provide you CLI, command and interface. So from CLI also I can manage my Windows operating system. So if I want to do something in my Windows operating system, I can do it from here as well, from my mouse as well, and I can do it. I can open the command prompt. From the command prompt also I can manage my Windows operating system. Let's say I want to create a directory. So if you want to create a folder, usually what we do, we go to our file manager. We click on the right click, then we click on the new button, we click on the folder, and then we create a folder. Let's say test folder. So if you want to do it from this kind of UI, you can do that. There's no problem. Okay, but we can do it from the CLI as well. How to do it from CLI? We have some commands available. Let's say mkdir is one of the command, and I can say I have to create a folder test 123. This folder will be created. So you can interact with your operating system via both your interface as well as your CLI. But in case of Linux operating system, we usually use your Linux operating system for creation of servers and management of servers. That's why in most of the Linux operating system, you will see, okay, only CLI will be enabled. Okay, only CLI will be enabled. So only via CLI, we will be able to manage our operating system. But in Linux also, we can have this kind of interface. We can use mouse and other stuffs. That is possible, but mostly we will be using command interface. That's why here also, okay, if I go back here, you can see right now I have logged into my my virtual machine, and they are giving me some kind of CLI interface over here. So whatever I have to do in this operating system, I will have to do it from this particular terminal. Okay. The first thing which I will do, I will log into my root user. So we have a command sudo su root. Okay. Sudo command means, su command means that I want to switch user. So in an operating system, like in Windows also, you can create multiple user. I can create one Sudhanshu user, dev user, a lot of users you can create. Similarly, in Linux operating system also, you can create multiple user. Last time I was logged into a user called as EC2 user, which had limited privileges, you can say. Now I have logged into root user. A root user is your admin who has all the permissions. Okay. So in Linux, we have a way we can create multiple users. We can set their permission. We can set a permission like EC2 user will not be able to access some certain file. Only my root user will be able to access it. So all these settings is possible. We can do it. That will come under Linux administration. We will not go to that direction for now. We have just switched to a root user. Now, if you wanted to switch to directory, we have CD command. If you do slash, then it will take you to slash directory. Okay, slash directory. And if I do pwd, it will show me all the my current directory where exactly I am present. And if I do ls command over here, it will show me all the directories which are present in my current directory. So in my slash directory, I have these many commands. So in your Windows, you normally have your C drive. C drive is very important for you, where you have all your kernel level packages, all your system level configurations. Okay. Similarly, in Linux, we don't have C drive, we have slash drive over here. Slash drive is very important. Here it will have all your kernel level packages, software configurations, everything will be there in the slash drive. And you can see a lot of pre-created directories, folders are present over here, which we may use. Okay. Now, if you wanted to create a new directory, you can use mkdir command, make directory command. What it will do, it will create a new directory for you. You can give a name test directory. So what you will see, this directory will be created. If I use ls command will list all the directories, all the files present over here. So you will see somewhere my test directory will be created. Test directory is created over here. If you wanted to switch between directories, we have a command cd command, change directory. I say cd, right now I'm in my slash directory, but I wanted to change to my test directory. So I will enter to test directory. And if I again do pwd command, now you will see I'm inside test directory. If I do ls command, do I have any file over here? They are saying, no, you don't have any file. So if you want to create a file, what you can do, we have a touch command. In case of Windows, if you want to create a file, it's very simple. Just click on the right click and then click on new. And then you can mention that I want to create a text doc. But in case of Linux, we don't have any kind of UI. If you want to do something, you have to do it from a command only. And here we have a touch command. And I can give my file name. My file name is, let's say, a.txt. And if I do it, and then now if I do ls command, you will see this file is present. Okay. In Windows, if you want to open a particular file, we usually have Notepad. Okay. So if you go to a particular file, let's say I want to read it, I double click it, it will open a Notepad for me, or you can use VS Code kind of editor as well. You will be able to see a particular file or the content of the file. Here, if you want to see a particular file or content of the file, we have a cat command. We have a command over here, cat command. Okay. And we then give the file name. It will show you the content of the file. Right now, my file is empty. That's why they haven't printed anything. They are saying this file don't have anything. Because touch command is going to create one empty file for you. If you wanted to add some data in this particular file, then we can again use cat command. And we can say cat command, I am going to provide you some of the input from my keyboard, from my standard input device. You have to take those data and you have to store that data, forward that data, move that data to your a.txt file. Or redirect your data. Redirect is the correct word. It will redirect your data to a.txt file. As I will enter it, now I will enter hi, hello. And then I will do, if you want to come out from this editor, you can do Control D, Control plus D. Let me type it. Control plus D. As you will press Control plus D, you will come outside of this editor and now your content will be stored. How can I see? I can again use cat command, cat a.txt. You will see hi, hello is being printed over here. Means my file was stored with the data which I wanted. Right? In Windows, if you wanted to install any kind of software, so what we do, we go to internet, and in the internet we search for the software. So let's say if you want to install anything, for example, you want to install, let's say you want to install Paint software. So just search for the software. Okay, install. I already have Paint installed, but let's say you want to search for software. You can just give that name. Okay, go to the website, download the exe file for that particular software, double click that file, and that particular software will be installed in your operating system. In case of Linux system, if you want to install any particular software, okay, we have a package manager, and in case of Red Hat Linux, we have a package manager called as Yum. In case of Ubuntu, we have apt, right? So if I want to install a package over here, I have to use Yum command. And I have to say, Yum, I wanted to install a package. And guys, now in this particular system, I'm going to configure a web server. So here I will say Yum install. I wanted to install a tool which can configure web server for me over here. Okay. And here the tool name would be HTTPD. This is nothing. It is behind this is Apache. So if anyone of you are aware about Apache, just search for Apache over here. Apache web server, not the bike. Apache web server. So Apache will help you to host a website or web server, you can say. So right now in this particular EC2 instance, which I have created, the virtual machine I have created, I wanted to host a web server over there. That's why I'm installing this particular software in my operating system, in my Linux operating system. Apache I'm installing. And here the software name is HTTPD. That's why I am going to run a command yum install HTTPD over here. As I will enter it, it will try to search for this particular software in the internet. And when it will find it out, it will download it in my system, and then it will also install it. And you can see they have find out this particular package. They are saying that we have find it in my Amazon Linux repository. This is your package name, and this is your package version which I'm going to install. And this package has a lot of dependencies as well, which I'm going to download for you. This will be installed from the internet. Your virtual machine, your operating system must have an internet connectivity to install these packages. Okay, so they are saying, do you want to install it? I'm saying yes. You can just press Y. What will happen? They are first going to download these things, and once they will download it, they are going to install it. So in case of Windows, normally your packages or your softwares are with the extension .exe. In your mobile phones, you have applications with the extension .apk. In case of Linux, we have our application with the extension .rpm, Red Hat Package Manager. RPM. You can see all the softwares with the extension RPM. So we are first downloading these packages. After downloading these packages, we are installing them as. And once your package will be installed, you can do RPM-Q HTTPD. This will tell you, Q means I want a query for a particular package. Red Hat Package Manager, I want a query for a particular package and the package name is HTTPD. Can you please tell me if this package is present? So they are saying, yes, this package is present over here. That is your package information, your package name. Means I have successfully installed a package over here. Okay, that's what we have to do. Now, if you wanted to start this particular Apache software which we have installed, so how can we do it? In Windows, if you wanted to start any of the program, what you usually do, you search that program in the search icon. Let's say I want to start my Netflix application. So I just search for that application and I click on the open icon over here, button over here. As I will click it, my application will start. Okay. In case of Linux, we don't have this kind of interface. So if you wanted to start any kind of software, we have a command, and the command is systemctl command. Systemctl, behind the scene, have a systemd, which is our system manager. And systemctl, can you please start a service for me, application for me, whose name is HTTPD. And as you will enter it, they will start this particular software for you. So first they have installed it. Installed means it was installed in my hard disk. It was not in running state. Now it is in running state as well. So if you use the status command, systemctl status command, and what you will see, oh sorry, spelling is wrong. Status command, they will tell you that your Apache server is currently in the active state, running state. It's currently running in your system. If it is running, it means anyone who will come to this particular virtual machine, they will be able to see the web pages which is going to be exposed by my application. Okay, and now if you want your custom web pages, let's say your developers have created some HTML file, some CSS file, and you want to host it in your web application, then you will have to give those file information to your Apache web server. And by default, your Apache web server listen or read all your web page content from a particular location, and that location is var www/html. Now, these information you can find it in the documentation of Apache. They will explain you about these locations. And right now you can see in this location, I don't have any files. But if you want to create a file, I can use cat command. I can say cat command. I want to create a file. The file name will be index.html file. Because mainly in web server, we serve our web pages, and web pages are usually created via HTML. Okay, HTML, CSS, JavaScript, client-side JavaScript. Okay, so whatever your CSS file, HTML file, JavaScript file, client-side JavaScript file you have, you can put all those files in this particular location, and then you will be able to use them. So in my case, let me create a new file. I will just create a simple file. Let's say I will add some heading tag as well. Let's say, hi, welcome to the Linux web server, and then let me close this heading. I'm just adding a heading over here. You can add a paragraph as well. Hi, how are you? Okay. So you can write your entire HTML, CSS, JavaScript code. I'm just writing a simple code, and then I will press Control D. I will come out from this particular command. Now, if I say cat command, first of all, can you please tell me if I have a file? They are saying, yes, you have a file, index.html. Then I will say, can you please read this file for me? They are saying, yes, you have this particular content in this particular file. Okay. Now, if my users wanted to see my content, so what they have to do, they have to find out my IP address, and then on my IP address, as they will hit, they will be able to see my content. Okay. So if I go back to my AWS cloud, where is my AWS cloud? Here is my AWS cloud, right? Here, I will go back, and then I will go back to my instance over here. So guys, your instance will have two kinds of IP address. One is public IP address and one is private IP address. Okay, private IP address is only accessible within your local network. But right now, my EC2 instance is running somewhere else in Mumbai, and I am somewhere else. I am in Prayagraj right now. So from here, I have to connect to my virtual machine, okay, via internet. So I will need the public IP address. I can copy this public IP address. I can go back to the browser. I can hit it, okay, and the port number will be 80 by default, and I will be able to see my content. But you can see it is saying this site can't be reached. Why? Because when you set up your virtual machine behind the scene, your AWS set up a firewall as well for you. So this is my virtual machine which is being set up, operating system which is being set up by AWS virtual machine. And here I have started my web server. Web server. Now I am the user who is somewhere in the internet. I wanted to use my website. So I will try to connect on the public IP address at port number 80 by default. Okay. But in between here, there is a firewall. Okay. This firewall is also called a security group in AWS. In this security group, there is a rule created. The rule is saying that only allow the outside traffic. If anyone will try to come to your operating system, only allow that particular person, only allow that particular traffic, which is your SSH traffic, which is coming from SSH protocol. And right now I'm using HTTP protocol to connect with my server. So only when someone will come to my web by EC2 instance by SSH protocol, and SSH protocol works at port number 22, then only allow them. No, don't allow anyone else. That is a present rule, you can say. Okay. So you can think of security group as a security guard. So you have a apartment. In that apartment, you are running some website, some application. You want the outside people can access it, but right now your security guard is not allowing it. Security guard is saying only a particular set of people can go to the apartment. Other people are not allowed. Okay. So I will have to update my security group rule. So if I go back to my instance, okay, you can go to security section. Let me just go back. Let me select my instance once again. You can go back to security section. Then here you will see the security group which has been attached. Click on the security group. Then here we have two kinds of rule. One is called as inbound rule. One is called as outbound rule. Inbound rule means who can come into my operating system. Like from the outside world, who can come in my operating system. And the outbound rule means where exactly my operating system can go in the outside world. So in the inbound rule, it indicates only someone who will come via SSH protocol will be allowed. No one else will be allowed. So I'm going to click on edit inbound rule and I'm going to add one more rule over here. And I'm saying, can you please do one thing for me? Can you please allow, let's say, HTTP traffic as well for me? Then they are saying, okay, do you want it to allow a particular IP address? Okay. So only that particular IP address, so that particular person will be able to access or will be able to connect to my web server. I'm saying no, allow everyone. So whenever you see an IP address kind of 0.0.0.0/0, it means anyone in this world can connect to my EC2 instance, can connect to my server. And I can click on save rules. My rules are being saved. Okay, I will go back. I will refresh my content once again. And let's see it is working or not. Okay, so we are still trying to connect. Okay, so let me just copy. You can see here we are trying with HTTPS, but I haven't set up any kind of SSL certificates over here. So I will be using HTTP protocol only right now. We haven't set up any certificates. And as I will hit, you can see it is giving me the data which we have defined in our website. Same, let me paste in the chat as well, Zoom chat, so that you guys can also connect with the server. Okay, so you can see the content. Now, this content is very basic content, but it can be a full-fledged website like Amazon, where you can have multiple buttons, multiple colors, multiple icons. Okay, multiple different cards can be there. It can be full-fledged website with HTML, CSS, and JavaScript. Okay, right now it's a very simple one. If I want to update anything in my website, I can go back to my terminal. I can say that whatever website I have, it is currently fine. I want to update something. So I can go back to my index.html file and I can update my content. And right now I can see that my terminal got stuck. So guys, this may happen with you sometime. If you will not keep on using your terminal, then it may get stuck. You'll have to re-log into your EC2 instance. So it will appear in some time. Okay. So now let me reconnect. And I will again log into my root user. And let me connect to var www.html. Okay. And now here, I would like to update my file. So I can again use cat command. Okay. And if you have a file, that is here, the file is index.html. And if I do the cat and again do the index.html file, and if I give some content over here, what you will see, my content will get override. If I again see, you can see my older content has been now been override with the newer content. If you don't want to override, you want to keep on appending the content. In that case, here you can use two times this symbol. It means please keep on appending the data. Don't override it. And now I can write my other content. Let's say I will write one more heading. Okay, web server running, and then let me close this. I'll do Control D, and then I will do again index.html. You can see my older content is still there. I have just appended my newer content, and if you go back, you just refresh your website, you can see the newer content over here. Okay, that's how it will be working for you, right? So guys, this is a website, simple website we have created, but we are also going to deploy some kind of full stack website by day number 3. Okay, right now we have just created a simple website. Okay, so guys, is it clear till now? So Isha, you can hit to slash index.html as well. Okay, thanks Roy. Like how should I provide the code? I will have to check with my team that if do we have any centralized location where I can put my code, or let me do one thing. Let me create a GitHub repository so you will be aware about repository as well. So guys, you can see this is my GitHub account. So GitHub is one of the account, like you can see one of the scenario now. I am the one who have created some code. Now I want to share this code with all of you. How can I do that? So I will have to store my code at a centralized location. And for that, I'm going to create a repository. So I will go to my GitHub account. You guys can also go to GitHub. And in GitHub, you can create your account. Very simple. They will ask you for email ID. They will ask you for your GitHub username. And you have to set up a password. Your account is ready. Very simple, straightforward. So just go to the internet and just search how can we create a GitHub account. It's very straightforward. Just search GitHub account create. So they will ask you for the email ID. Okay, it's free. You don't have to pay anything. They will ask you for the email. In my case, I already have the account created, so they are doing the login for me. But in your case, they will prompt you for the email ID, and you can give that email ID, and you will be able to use it. Okay. So in my case, account is ready. So what I will do, let me go back to my main GitHub account. I'm going to repository section, and then the repository section, I will say I wanted to create a new repository. I will click over here. Then I will give a repository name. There's a name will be GFG hyphen workshop. Any name I can give. 2025. Okay. Then I can give a description as well, like the data for GFG workshop 2020, 2025. Now I can decide who will have access to my repository. Because right now I'm just sharing you some common code. But what you will see later, I will be putting my company's code. Let's say in Instagram, they will be putting their Instagram source code. And they don't want anyone can access it for security reasons. So in that case, they can put their repository in private mode. When I put in private mode, then only those people whom I will allow, they will be able to see my repository content. But right now, because we have a wide audience, I will make it public. So anyone in this world, if they will have my repository link, they will be able to see my content. And I will initialize my readme file as well. And I will create this repository. So guys, you will see a new repository will be created. Okay, GFG Workshop 2025. Let me share this link with all of you. Okay, in the chat box. So you guys can connect with this repository. You can start this repository so that you will not lose it. And then I will upload all the screenshot which I have created over here. Some extra document also I will upload over here so that you can revise the concept which we have learned today. And then I will upload the code as well which we have created. So everything I will upload in this repository itself for this workshop. You can manage the entire code from here. Okay. So I hope this is clear. Guys, let me stop sharing my screen for a second. Let me connect with YouTube as well. And I want to see in YouTube also if someone have any doubt. So let me see the YouTube chat as well. Just give me a second. Click here to add it. Okay, so okay, I hope it is there now. Let me share my screen once again to all of you. Where is my Zoom? Okay. So now, guys, everyone is free to ask their questions, whether you are from, whether you have joined from Zoom or you are from, I think, YouTube. I'm not sure if it is being updated dynamically, or I don't see any much queries over here. Yes, so Kunal, I will say Linux is the base. If you wanted to work in DevOps, Linux is the basic requirement you should have, because whatever tools we are discussing, we discuss about Jenkins. Okay, in future we will discuss about Kubernetes. Okay, when you proceed ahead with DevOps journey, you may hear about Terraform, Ansible. Okay, mostly everywhere we would be using Linux operating system, so we should have a good knowledge of Linux operating system. Although in the given time we can't cover everything, so only the basic things I will be covering, which will be required for our project. Okay. Okay. So let me just upload the GitHub link here as well. It's a good point. We copy this and just give me a second. I'm not able to view this. How to chat? Okay, here I will paste. Okay, so guys, I have given the GitHub link in the chat as well. You can get it from there. Okay. Now, from the Zoom also, if anyone have any doubt. So guys, I took some extra time today, but this class, tomorrow also we will have the class at the same time, 7 p.m. to 10 p.m. And day after tomorrow also we'll have a class from 7 p.m. to 10 p.m. So see, my agenda for this workshop is to explain you and to give you a taste of DevOps. DevOps is a very vast tool. Like in Geeks for Geeks, I have so many trainings on DevOps where I provide the entire end-to-end training for DevOps, where the course is almost for 80 hours. And here we have only 9 hours. So I will not be able to cover everything, but only those components which will be important for our practical, our final goal. Our final goal for this particular workshop is to create a movie streaming application where it will be a full stack application. Okay. And I will be creating a CI/CD pipeline with integrating it with Kubernetes. And in Kubernetes, we are going to deploy our entire server, our application. That is the final goal, final practical, final project we are going to create over here. So a movie streaming application we are going to create. Then via CI/CD pipeline, we are going to properly test it. After testing it, we are going to deploy. Okay, and then it will have a front end, back end, and database. All three things will be there. Okay, that is the final goal. So whatever will be required for this particular project, I will be explaining. Okay, so attendance form, I am not sure if there is any attendance form as well. If anyone is from Geeks for Geeks, please share that over here. Yes, Uday, this workshop will give you a very basic about cloud computing, because eventually everything we are going to deploy in AWS cloud itself in this particular training. So a basic idea you will get, a basic taste you will get. But if you wanted to learn in detail, I can share you some extra resources. I have my course for that as well, where you can learn more about it. Okay. So, okay. Thanks, Ronak. Okay, that is a very good point, Sarad. I think you're asking some very good questions, I will say. And I will recommend that with all of you. And guys, because there are so many questions popping up in my screen, it's not possible for me to read all of them. I will recommend you all, if you know about the answer of a particular question, please try to help others. I can see some of you are already helping. This is very good behavior. So, Sarad, I will come back to your question. So, for making it HTTPS, okay, a lot of certificates we will have to create. We'll have to add certificates as well. That will again be a proper 9 to 10 hours of training only for making our website HTTPS. Okay. So we'll not go to that direction, but if you want, okay, I can share you some documents. So let me share my LinkedIn as well with you. You guys can connect with me on LinkedIn. And if you have any doubt, which I was not able to cover over here, so extremely sorry for that. In that case, you can directly ask me on LinkedIn. I will try my best to look into your queries and help you over there. Okay, and if anyone wants some extra document to practice, Geeks for Geeks already have those documents available. I will give you the link on that. Okay, course link again, Geeks for Geeks team may share that with you. Okay, so my next batch is like currently I'm running a DevOps batch, which is going to be completed by the end of June. After June, I may take a new batch. So my Geeks for Geeks team will update you about that. And in firewall, if you make it HTTPS, so it will not work, sir. Okay. Okay, because HTTPS and HTTP works at different port, so it will not work. Okay, it will work on port 43, and your HTTP works on port number 80. It will not. Again, for certificate, my team can tell you. I will check with my team if uh, they have any certificate as well for sure. Okay, so CI/CD pipeline, how to create Vanshika, we will cover this in tomorrow's class. What is Docker? I will cover this in tomorrow's class. Okay, so both Docker and CI/CD will be covered in tomorrow's class. Let me check in YouTube as well. Sorry, I missed YouTube. Okay, so you are saying, Shivan, that what key resources is duplicated in virtual machine but shared among containers on a single host? What key resources is duplicated in virtual machine? Okay, so you are talking in containers. Okay, so let me just give you a basic overview of containers. Again, guys, I will just take 2 more minutes to give you overview of containers. I can see some of you are asking questions on that. So what happened now? Okay, so let me draw a final diagram that will give you a small overview of containers. So now we have took the hardware. Okay, this is our hardware. In top of this hardware, we are using this virtualization technology. We are using hypervisor tool over here. And with the help of this hypervisor tool, we have created multiple virtual machines. That is the setup we have done till now. But this is not the final setup. In real world, we have few more steps over here. So in each of these operating system which we have created, okay, now in one operating system, we can run more than one program as well. Okay, but how will we manage the security of this program? Let's say here I am running, let's take an example again of Paytm, for example. In Paytm offer you one service where you can book your rail ticket, right? Paytm also offer you a service where you can book your, let's say, movie ticket. And let's say the code for both of these services are different, and I want to deploy both of them on the same operating system, not in different operating system. Okay. In this particular case, what will happen? How will I take care of security with of them? Let's say someone have hacked my this particular microservice. Okay. And if they have hacked my this particular microservice, they can also hack my other components of operating system as well, which can be very, very critical for it. That's why once you have an operating system created, we wanted to do a virtualization at operating system level as well. So this is called as OS level virtualization. Okay, and this comes up with the containerization technology, and one of the pioneer tool in the containerization technology is Docker. So with the help of Docker, now we will be able to deploy more than one microservices in the same operating system, but each one of them will be independent from each other. Each one of them will have their own IP address, their own network setup, their own storage, their own credentials, confidentials. Everything will be independent. So once our operating system is ready, we can also do a OS level of virtualization that I will explain you with a proper example in tomorrow's class. And then you will get an idea how exactly microservices are running in the real world. So in real world, microservices will run on top of your Docker. Okay, we haven't discussed about Docker much yet, but I will show you tomorrow in tomorrow's class. Yes, and once Docker is completed, we will discuss what Kubernetes is. The ones I will say that you can look for some of the startups. Startups will be good for you if you are a fresher. A startup will hire you. The only thing they will require is you should have a good projects in your resume. So one of the project I'm going to show you in this workshop, but you can create few more projects. Okay. If you want, I can share the code for the other projects as well. You can check out my repository. In my repository, you will find out multiple projects regarding DevOps. Okay, this is a repository. Sorry, my GitHub account, you can say. In GitHub account, you will find multiple repositories which has the different kind of project. You can check the README file for all these projects and you will be able to do the setup. So let's say if you want to set up a MERN application. So here is all the files and here is the architecture and here I have given the entire README document for that. Okay, so if you want, you can go with these data. If you're stuck somewhere, reach out to me in LinkedIn or somewhere. I will try my best to help you. Okay. Anyone else? Where will be the beta phase will be used in this code? Again, Vamsi, it will depend on our use case. Okay, we can create multiple phases as per our requirement, but in real world, in most of the cases, you will have dev, QA, staging, and pre-prod and production. This much is in it. Okay, materials I will share with you directly in my repository. Okay. Okay, so you are saying so that you have deployed some Spring Boot application, okay, in different port like in one 8080 another. Yes, you can do that. There's no problem. If you wanted to containerize it, I will show you how it can be containerized. So tomorrow I will show you for a Python application how to containerize a Python application. Okay, but if you want to containerize a Spring Boot application as well, same steps you can follow. Only the commands will change. So I will give you the approach in tomorrow's class, sir. How can you do that? Okay. Yes, I think, Roy, for all the projects, we will be using AWS over here. So you don't have to do any kind of setup in your local system. Everything we are going to do on AWS cloud. And whatever services I'm going to use, most of them will be free of cost. So you don't have to pay anything to AWS as well. You just have to create a AWS free tier account. That's it. Okay. I think I have shared my GitHub. If you want it once again, let me just share my GitHub once again with you all. I think, guys, we have exceeded the time now. Um, we will continue our discussion in tomorrow's class. Okay. So let's see in YouTube also if anyone have any queries. Okay, so that's all from my end, guys. I think that's all for today. We will continue our discussion in tomorrow's class. We'll build for tomorrow. The agenda will be to build a CI/CD pipeline and to also learn about Docker. So today we have covered all the basic part. All the, you can say, base is now clear for all of you. So in the base we discussed about cloud computing, what is virtualization, what is virtual machines, how to create a normal server, what is Linux operating system. So these are the basic things we have covered. Tomorrow we'll go ahead and we'll learn few more things. So let me stop sharing my screen, guys, and let me check some more queries if you have. Okay, so that's all, guys. Thanks and good night and bye.